So day one session, byte pair encoding, we had a discussions, and then cosine similarity, and then word embedding, vector. In vector, we will be discussing about dot product, cross product. This is what we had discussed. And then what else we had discussions? Tokenizations. The tokenizations and byte pair encoding on the same topic. Okay, so those are all we had a discussions already. So in future classes, today we will be going to discuss about positional encoding. Once positional encoding is over, then we'll be going to discuss about attention layer. This attention layer we will be going to discuss about the single attention, multi-attention, and the mask. So during this attention layer, you must know that algorithm, the backend, what is happening with the Softmax functions, and then sigmoid and gradient descent, and then we will be going to discuss related to back propagations, forward feed, back propagation and backward feed is close to the same, and then layer normalizations. I'll mention here. Layer normalization, and then we're going to see with residual. Okay, so these are the mathematical topics. Once we have discussed all this topic on the upcoming session, and then we'll be going to continue and do some practices with create small language models, your own SLM. So this is completely Python, but you must know the mathematical behavior. That's we are planning to discuss. Once you have discussed this one, then we will be planning to do something with the Android deployment and performance with the quantizations, KV caches, and much more things is available. What are the priority? That's I would like to discuss with you. This is the as of now agenda. This is one for GPT. As of now, I am discussing everything with the GPT architecture model. Because attention, all your need is completely related to the GPT architecture. So that's we are trying to discuss. Everything is done. I would like to continue the session with another LLM model with a DeepSeek. Gwen, and much more things is available, Gemma something. So these are is look like similar to GPT, but there is some changes available. We are going to discuss what is happening because attention is going to be different each of them, and the behavior, that LLM model behavior is a bit different. So each of them we are planning to discuss end to end. The agenda. We are planning to discuss here the entire topics as much as possible. We will be planning to cover here the input embedding. We will be going to start with the byte pair encoding and then word embedding and cosine similarity. These three we are planning to discuss today. And next week we'll be going to start. This is I'm not sure to complete within today, and I would like to show some programming that I can for you. So I would like to complete everything together in the today. Otherwise, phase two will be continued with the word embedding and post coding by next week. After that, multi-head attentions, the kind of we have causal attention is available, and self attentions, and multi-head attentions, multi latent attentions, group recovery, paged attentions, flash attentions, multiple attentions because different LM is going to use it. Next 2 to 3 weeks, I am planning to focus mostly in this MHA, how it is working the backend behavior. This is my plan to discuss. And the normalization concept, and we'll be going to say with feed forward and the residual normalizations, layer normalization. These are I'm planning to cover in the top of something. This is the plan of the agenda. The same, this is the encoder model, you know very well. Same like decoder, we have the same, so we don't have much differences here. So we will be going to recall what it is, and the master multi-attention is a small differences to compare with previous multi-attentions. So we are going to do the comparison between them, and we can do the practices, and we'll see everything with the importance with the mathematics, and then we'll be going to see with the programming. Because programming, you can Google it, you can get yourself, and you can retrieve by yourself. That's not a problem. But the behavior in the mathematics, that's very, very important. That's I'm planning to focus on these topics. Okay. So any questions you can ask me now? Okay, fine. So no questions. This is the agenda. Um, so I tried to complete as much as, and somewhere something related to, we are going to discuss about matrix concept and calculus, trigonometry, um, such things, multiple things is available. So I'm planning to cover one by one, and will show with high level the references, because I don't like to go in the depth level. So wherever you struggle, just ping me in the teams, or you can ask me in the meeting itself. This kind of problem. The agenda and plans. Okay, shall we start now? Any question you can ask me. Okay, fine then. So I'm going to start with how simple. To start with the BP first now. Mm, you can only see it's a simple. If you have chance, you can get the notes and you can follow with me. That's easy for your understanding. Yes, I'm audible. So network is slow a little bit. Will excuse. Okay. So first, byte pair encoding. So we will be calling as a BP. This is the basics for your tokenization concept. So the tokenizations, it will be referred based on the byte pair encoding, and then it is converted into subword tokenizations. Okay, this is the simple understanding. Subword tokenization is nothing new. BP start with the character level, like each character just going to be refer it and do the process. Right, let me check it. Subword tokenization will go with the word level. Okay, this is the major differences. So during this subword tokenization, the people are going to use with one not encoding. They will be going to skip grams, n grams. These are all the NLP references I'm saying. After that, they are going to use with the embedded matrix. Okay, so this is the people are nowadays they are using it. Mostly LLM model prefer and go with embedded and matrix only. This is what we are calling as a word embedding. Okay, so now what we are going to see how the byte pair encoding works, because this is sometimes in the interview perspective that people are asking, and then we'll be going to see some example with the similarities, uh, kind of how the word level is working with the similarities. Cosine similarity, the concept is available. That's we are trying to discuss. And then we will be going to use real time some sample vocabulary size with almost a 50,000 K vocabulary data set we can take and check with this word embedding and compare with our cosine similarities. Yep. This is the plan agenda. Okay. So why I am taking this BPE? basic references, it will be used to making all your topicalization this word level based on this references too. Okay, there is some connections available because we cannot explain everything together, but you can get the information from it. Got it? Now I'm going to start with the BPM. So BPM nothing but you have a text, multiple character will be combined together. So the example actually the paper is in the A B A B C A B C D. Total 9 characters there. Okay. So how it's going to be reduce it and how they are going to pair with each words. This is the concept of byte pair encoding. Each byte character level is each of them is a 1 byte. So how the pair is going to be combined together and they are going to add. This is the main use of byte pair encoding concept. Now I'm going to create some index based on this values. Total I'm using only 4 letters. ABCD only I'm using it. I'm creating indexes. So this is I'm directly pairing with. Okay, so there's a easy understanding. Index references. I'm just using it. This is character. There's the index number. It's going to be infer with your actual value. It moves to split A pointer, B pointer, C pointer, and B pointer. Okay. Now I'm going to combine together A and B as a paired division. So the paired character. So what I can do, A B is a pair. AB is a pair. I'm going to create with E. Okay. So if I suppose to convert this one, E, E, C, A, sorry, because this is also one of them. This is one of them. Total 3 times AB is coming. So E, C, E, C, D. This is the meaning for this pairing. AB I just compressed and create as a E as a word. This is I'm going to mention this one pair. This is clear everyone? Any doubts, any queries? This is phase one. Okay, so now E I just combined and then what I'm going to do is I can add one more pairing here itself. You can notice it. EC is a comment. We will be getting frequently this again. So this is I'm going to combine together. This is phase two. I'm going to do that. So this is I can mention with F is E and then EC is a F, EC again is a F and D. This is the phase two of compressions I'm doing. Okay, so total here EF, DFT, we cannot do any pairing here. This is the final one. Because if suppose we have the same EF and EF, we can pair again and we can create with a single byte. Unfortunately, we cannot compress this one. They're the final compressions for this. This value is an input string. They're the final input text.
Actually,
They're the final.
based on what you decided to take 2 letters, actually, Dinesh, I'm trying to
Which one?
understand that. If you look at the P1 part, you took AP as a pair, right?
Yeah, exactly. And
Based on
this is
what
the
you
E
decided
is a
that,
keyword.
yeah,
Pair means only two.
only 2 letters, right? Only two, not more than.
Yeah,
Okay.
yeah,
Mm,
yeah,
mm, mm,
exactly.
mm.
So AB,
Why? Because,
AB, AB.
yeah, yeah. Okay. Then if you take 3 letters, we can achieve
Mm.
4 letters at the
No, it's going to be
P1.
collapse. Only pair basis we have to do that.
Okay.
Even
Okay.
in your
Only
real
two.
time words, you'll be going to split based on the two only. Example, doing is a word. You're going to split
Okay.
do ing. Pair only you can do that. If try to
So
make
it's
more
pair.
than two, then this, yeah,
Okay, it's pair. It's clearly telling that we have to go for two split, right?
exactly.
Okay. Okay.
More
Okay.
than two, only GPT-3 model they are going to use it. So
Okay.
less
Mm.
than that, there is a lot of complexity, and you have to use a
Okay.
lot
Got
of
it.
computations. That's why the
Mm.
pairing the people are trying to use it. So DeepSeek
Okay.
model
Here
also
only
they are
two.
using with more than two.
Okay. Got it.
Any other question, guys? Same 2F we cannot do that, unfortunately. It should be a pair, meaning it should be a different letters. Same letter, we don't want to make it together. That's why. Here you can see E is available, but we are going to pair this two only. Different letters, we can pair it together. That's an important. Any other questions? Okay, fine. So there's the final text. This is the actual string. So this is almost a 9 character. This is only for 4 character for us. I just trying to compress it. This same compression model only, your real-time tokenizations model, everybody is there using it. If you are going to check with OpenAI tokenizer, GPT-2, 3, 4, they are going to split the word and make the tokenization to reduce the values. Because each word that a character is supposed to make the token, it will be more cost for you. That's why they are not using it. And this is the character level tokenizations we are doing. It's supposed to go with the word level. This is the word level example. So any words is available, grammatically they're going to split that, or the noun basis or meaningful, whatever the meaning is available, space based on the spaces, comma, they're going to remove it. And they're going to split the paths. And stemming, limitation, these are the concepts for the NLP basics. I don't like to boring you in this one. So these are all they are going to use up different perspective attention to the backend with the vector sizes, and they are going to split the words. But this is the basic agenda. They are going to use it as it is. Is it clear now? Shall I go
Yes.
next?
Yes. 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 Yeah. Yes.
Others, do you have any queries? Okay, fine then. Okay. So next, what we are going to see, cosine similarity. Okay, because why I am taking this byte pair encoding cosine similarity during the word embedding, these are also metrics we are going to use it. At the time, it's very difficult to understand. That's why I'm choosing this one. Okay, now cosine similarity, we can take some sample examples. I'm going to take some samples. Mm, completely partial and we can do similarity, partial similarity.
So all these are internals of LLM, right? Internals.
Exactly. Exactly. These are all while you're going to practice with multi-head attention at the time. This is very important concept for you. That's why I'm taking it now itself.
Okay. Yeah.
Okay. 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 We'll take this sentence, the high similarity we are seeing. How it is high similarity? We're going to compare. Okay, this is easy. I am taking this easy because we can understand very much. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4, 5. 2, 3, 4. Okay, so I have to compare both. Otherwise, you may be confused with the matrix references. I take 5 records 1, 4, 3, 4, 5. 5 words. In both of them have a 5 words is available. Now I am going to compare it. Later I am going to compare with non-one word. Okay, so do the plan. Okay, first what we can do, this is we can use it and go with one-hot encoding model, simple understanding with the NLP, and then I will show one real-time example with the word embedding model with the vector basis. Okay, so now I'm going to compare both the unique words, both of them. Now, come help me. Let me just okay, so the word the I'm going to sort all the values and we'll see that. Sun is okay, sorting is a different thing. I said it. Mm. First, it should be this is the first, okay, and then second sorting. And this is second, right? Second, H I. Okay, sorry. This is the heart is the first, I is the second, little is the third. Each word I'm going to sort everything together and we'll compare it. This is I'm doing correctly. Heart is the first, little second, sorry, is second, little third. This is second, little third, and then what else? Is so T, five, U, B, 6, 7. So I'm going to order it right now. So heart is a little
Sun, sun,
sand.
the
Thank you. G,
very warm.
very warm. Okay, so this is the ordered way. I just take it out. Now I'm going to compare this one and applying the one not encoding for A and B. So I'm going to apply one not encoding wherever the word is available. D is available. So
How
here
you
it should be
ordered this
one.
actually? Based on what you ordered it actually?
What all the word is available, that's I make as a one, otherwise it will 0. This is I'm going to do that right now. Got it?
So why can't we make very as one or warm as one?
Suppose at the time what
No.
will happen, the similarity with the dot product, you're going to combine it, it may be going to collapse. That's why we are doing the order. Those are the same order references, the vector embedding, they are using the backend. This is I'm doing with the one not encoding model. But the original vector embedding, they are ordered everything then only because they have vocabulary size almost to 50K minimum. So if it is collapsed, then model going to be confused and performance is going to be down. That's why the sentence piece and order they are going to do that. Okay.
Yeah.
Now is it clear, Mohammed? Is it clear for you? Yeah. This alphabetical order we are calling as a lexicographical orders. That's the people are doing that. In real time, you may be used numbers as well. So 50K records, I'm saying, right? 50K record, not only for the word, it might be combined with the numbers too. So everything we have to order it properly. This is an example. I'm taking only 5 out of 50K records. I'm taking only 5 right now for your references. This 50K vocabulary sizes they are going to maintain inside. At the time, this is maybe confused. That's why they are using sentence series or an ordering model. Clear, guys? Still any confusions? Okay, I'm going now.
This ordering, there is no rules, right? Actually, there is no rules.
Ordering is a lexicographical orders. That's the concept.
Okay.
Numerical order and lexicographical orders. Two types of orders available. But vectors as a vocabularies, everything they are ordering with sentence or the sentence they are ordered by lexicographical orders only.
Okay. Lexical order.
Yeah.
I will. Yeah.
Okay. Now I'm going to apply this value. This is the A sentence. This is the B sentence. I'm going to apply right now. D is a one. Sun also one. Is also one. Little also one. Hot also one. So balance this two. This is it. This is the value for your vector. This is the one vector I'm doing. Real time like this, multiple vector is going to be involved. We'll be seeing that after this topic. That word embedding model we are going to discuss. Now I'm going to compare the same for B. B also one.
For little, how it will be
So
one little, and little, how will be one little.
A sentence is available little here.
Okay.
This is the A sentence. So this is a one. Very
Oh,
harmonic, not
oh, okay,
available.
okay, okay. Okay, okay, got it.
What are
Okay.
the word is
Fine.
available? That's we can take it as
Hmm.
a one. That's it.
Okay, okay, got it. Yes, yes.
Third is one. Very one. 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 So this two, this
Part
is zero.
zero, little zero. Yeah. Okay, got it. Yes.
Okay. So there's that same. There's the same. Okay. So
Yeah,
now
yeah.
this is the value we are going to use it, and I hope you know the cosine similarities, right? I'll say this one. Mm, I will remove it here. So cosine similarities is a kind of dot products. We are using it. So this is the formula they are using as it is. Just copy it. That is very huge. Okay. So I'm trying to compare this to A dot B is a matrix multiplication. They are doing it, and then this is the inverse matrix of A, inverse matrix of B. They are doing it. There is the actual formula, square root of all the values you want to match it into square root of all the B values you want to match together. There is the meaning. Okay, now I'm going to apply this values into matrix multiplications A and B. A dot B equal to, I'm going to convert this everything into matrix 1, 1, 1, 1, 0, 0. Then the A, over the B. 0, 1, 0, 1, 1, 1, 1. Another B. I'm going to add it. This is actually 1 into 7. Yeah, this is 1 into 7. This is 7 into 1. I'm going to merge it. I can get the value because there's 1 into 7 and 7. Then final output for A and B should come with 1 into 1 only. Only one output you are going to get it. Matrix multiplication basis. Here you can say just one more. This is the transpose differences. Otherwise, you cannot add the multiplications here. A dot B is a kind of transpose only they're going to use it. Unfortunately, I cannot show you this one. There are transpose references. Otherwise, we cannot do the multiplication. Can you compare it? 1 into 7, 1 into 7. You cannot do the multiplications here. That's why 7 into 1 we are using it. Top should be the same. Then only we can get the value here as it is. That's why we are getting 1 into 1 also. Okay, is it clear, everyone? Any doubts still now?
No, what you are trying to say actually here? 7?
I am going to see the value.
Okay. Okay.
Okay, so right now this is the A dot B. I'm doing it. So A into B in the matrix multiplication. If you are going to do that, same orders will not be possible. So you have to transfer. Then only you can add it. That's why I'm taking one of them in the transport model to add it here. This is only one row, 7 column available. This is one column, sorry, 7 rows, 1 column available. This
Okay. Okay. Okay.
OHE I am
Row
going to
and
convert
column
it.
conversion. Okay. Okay. A
This
to
is
row and B to column. Okay. Okay.
exactly.
Okay.
Now
Okay.
I'm going to add this to. So what are the possible? We can extract them. So 1 into 0, 0, 1 into 1, 1, 1 into 0 again, 0. This is addition. This is the additions. Okay, so this is 1 into 0, until third is 0, fourth 1 into 1, 1. So everything 1 into 1, 1. First 0, 0. So total I'm getting 3. A dot B value is a 3. I'm getting it. So now I want to compare this two. Okay, this is A inverse and B inverse. Right now everyone is clear. I'm going to see this one. A dot B, I got the value as a 3 right now. Can I use Excel better? Hmm. I'll just type it everything here. That's easy for me. A, B, 1, 1, 1, 1, 1, 0, 0, 0, 1, 0, 1. Okay, there's the value. Let's save this file and close it. We can continue from here. Okay, so there's the value for A and B. I extracted right now. I'm going to apply with the matrix multiplications. So this is the A value and B value already available. I'm applying matrix multiplication. So as expected, this is the EAB value. A dot B matrix. I'm getting this value as a. Okay. Now second inverse matrix I want to apply. We'll do it. Board we cannot explain everything. Maybe once formula is over, the final output I can show you. Give me a
Yes.
second.
Yes. Yeah.
So inverse of A, inverse of B, that I want to do that right now. Okay, so inverse of A is nothing but the formula as per the formula, square root of A square. That's I'm going to do, which means I want to add all the value with the square, and then I want to get the value as it is. So I'm going to apply the square for this one. Okay, so I'm going to apply the squares now. Same only because it's a one not encoding, very easy understanding. That's why the same value I'm getting here. So this is I want to sum it right now. If supposed to sum, you're getting 5. Okay, this is normal sum. Just a square you have done it. Sorry, this is square you have done it. Root you are not applying. You want to apply the root now. Because you can see the formula square root of summation of all the value with the square value. This is a square root of a square. This is you are doing it. As of now, we just only add into square. We didn't take the root. I'm going to apply the root now. Square root of this value I'm going to apply. So 2.231 I'm getting as a output. Okay. Same like B I want to apply. This is I'm going to apply. The same because it's a one not encoding, only 1 and 0 you're going to see. That's why you're getting same output. In embedded matrix, you're going to get with the float values. So floating point is pretty difficult to understand. So this is also I'm getting 5 only. And if I suppose to take this one into square root of B, both are same output I'm getting. So this is also same 2.236, 2.236. Now I am going to apply in this formula A dot B divided by inverse of A and inverse of B. So A dot B matrix, I'm getting this one. So 3. First we will add this to multiply. Exact value. Okay. It's close to same. That's why we are getting for 5. Okay. So A inverse B inverse is a 5. A dot B product is the matrix product matrix. Product. Okay. And we're going to take it over here. B.
Think you are rounding, right? For value A into B.
Its actual value is a 5 only it comes. Because
Okay.
both have the same unique similarities. So we are getting 5 only. I try to
Mm-hmm.
get the floating point.
Oh,
Unfortunately,
23068. Okay. 236. Okay. 06.
same we are getting.
068. Okay. Yeah.
Now this value
Yeah. Yeah.
divided by this value. How much is it? 0.6 I'm getting right now. Okay. So this is
Mhm.
the cosine similarity value 0.6. Similarity. Okay. So already I said in this concept we are going to use with the cosine references. Why we are taking cosine? Sine and cosine we have small differences. Anybody who have knowledge in this trigonometry? What is the
No, I
difference
thought of
between sine
asking
and
this question. I don't. I thought of asking this question
sine
to you. Why were you
versus
saying that?
cosine?
Mm-hmm.
Okay, so here you can see this one. In trigonometry, whatever the data you're going to get it, mm, This is for this man. Okay, you can see sine always opposite divided by hypotenuse. Cosine always will come with adjacent divided by hypotenuse. Okay, you can see this triangle. Suppose you are going to take this references from this angle, opposite value divided by adjacent, you are going to get it. But in this vector, what you are doing it, A and B, this is not the opposite. This is, if supposed to you're going to create in the chart that vector references, how it can be created. Simple understanding what I'm saying. This is a similar we are going to compare it. If suppose you're going to compare that opposite exactly into this one example, this is the A value. If suppose you're going to compare this as a B value, you're trying to find the similarity near to this one. Near to A axis, how much is close to that? You don't want to find that opposite references. So this is adjacent, this is opposite. If supposed to compare it, this is hypotenuse. Okay, you are going to see the references here only. The cosine similarity goes this way. If suppose you are going to take sine similarities, it will be going this way. Okay, so those are sine references. This is cosine references. That's why we are going to compare this cosine references only, not with the sine references. Hope you got my point, what I'm trying to say.
Yes, got it. It's
Others,
horizontal axis, right? What you are trying to say,
yeah,
not
yeah.
on the vertical.
This is
Yeah.
adjacent. I'm trying to compare
Adjacent.
A adjacent of B only I'm trying to see. I don't want
Yes.
to see the opposite. A opposite B is not required.
Mm,
A adjacent B is enough. That's
okay.
why the cos they are using it. After this, you can see the cos theta they are going to compare with the dot product.
Mm.
Guys, you're able to follow me. This is a bit confused. I just give you high level references for you. Are you able to follow me?
Similarly, for tan also something will be there, right? Tan also.
Tan is
Sine
completely
cos.
different. Tan will
Yeah.
come, this flow is this way. Top and edge is going to be compared. Because this is going to be
Okay.
compared opposite by adjacent, not with hypotenuse. That's a tan. So
Mm-hmm.
tan is not required. We are trying to compare B and A matrix. How is close to that?
Okay.
Yeah, tan for tangent. Yeah, correct. So now we are going to see the references between this cosine similarity only, not with the sine similarities.
Mm.
Okay, everyone is clear
Yeah.
now? Okay, because it's very, very difficult. Even my understanding, I'm confused a lot why it is not sine something. Then later,
No,
I
diagrammatically,
understood.
I got it. Actually, the
Mm.
diagrammatically, I can able to understand. But okay.
It took
Yeah.
me for 1 month, to be frank and saying.
What?
1 month it took for me for this understanding.
Yes.
Why it's cosine.
Yeah. Yeah. Why this question? Yeah, that
Okay,
is really, we have to know that.
okay. So now we are going to see the inverse references for us for this one. So similarity value, I got it this one. This similarity, I want to apply the cosine references. How many of you have a calculator?
Yeah, it's with me actually.
Uh,
I am doing
Take your
calculation for that.
calculator.
Yeah.
Scientific calculator is that available. You can get the scientific
Y-
calculator here.
Yeah, yeah. It's with me.
Okay, so I want to
Actually, root
apply
5 into 2, it is coming
inverse of
4.472. Inverse of, huh?
which one? Yeah,
Actually, root 5 into
inverse
giving
of
it is coming around
0.6.
4.4. 4.472, not 5.
53. Inverse of
What is that?
cos you have to
Inverse
apply.
of?
Cos. Mobile, everyone have a scientific calculator. Can you open it and go to scientific? Apply inverse button.
Yeah. Inverse,
I will
yes,
show you
done.
this one. Inverse
Inverse?
of
Mm,
cos.
mm. Cos, huh?
And
Yeah, it is
apply
there. Yes.
cos minus 1 is the inverse references. 0.6, how much it is?
0.6, huh?
Uh,
Mm, It is inverse of cos. I don't know, but it is giving minus 0.00005, not the one which you are showing actually.
Yeah. Dinesh, can you please explain again this one? I'm just confused.
No, you have a calculator, right? First
Yeah.
type in button. It will be shift. It's kind of shift. It will lock. And then go to cos
Yes.
minus 1. Click on it. Then it will come or cos something. Point
Cos
6, we are
minus.
getting the output.
So why we
This
use
is
cos minus 1?
no, it's the inverse references we are going to get it here. You can see everything we are going to refer and we are going to apply with the inverse. Cos here, you can see this one. Cos, we have the cos here.
Okay.
This cos we have and we want to compare with our similarity references. Or whatever. So this cost references we want to apply into the inverse model because this is the output 0.6 you are getting it. So suppose this cos of cos theta only will come here. That's why we are going to apply here. Inverse of cos is you can convert into convert, then only you can get the value. If you are going to move this cos into this way, then it should be a zero references. Am I right? That's why inverse we are applying right now.
See, what I applied inverse of cos of 0.1, 0.06, right? What you mentioned.
0.6, yeah. What you are getting?
0.6. I put it in the chat actually, the screenshot of the
Okay,
calculator
one
actually.
minute. I'll check.
So I'm trying to understand what I'm doing.
No, no.
Inverse of
Inverse.
cos.
I don't know. This is a bit different.
Even I'm not sure actually. Okay, okay,
Others, can you
fine,
try?
fine.
Uh, no, INV,
Yeah.
not IN. INV. There is a button is available. INV.
Yeah, I'm also getting the similar result. Maybe this is in the
No,
Mac.
INV. There is a INV is available. One button.
INB, yeah?
INV
INV.
something. Yeah.
There
I
is.
will show my phone. Okay. I will type this one. I will share the
INB.
screen.
Hmm.
I will send you to the WhatsApp now. You can see.
Yes.
I send in the WhatsApp. There is a button INV, not IN.
INB.
Hmm. I don't know. Somewhere it's not available. Check with the scientific references if any alternative options. Or I will apply the same formula in Excel. Excel
Yeah,
for
yeah, that will be good. Yeah.
this was A cos. Okay, this is enough for me. Okay, so now this is the similarity. Cosines I'm going to apply now.
Hmm.
A cos this value. A cos is too much differences. 92. Something I missed. Maybe which one is correct? I'm not sure. Similarity. Degrees of A cos of this value 53 degree. This is the calculator.
See,
So
even
calculator,
in the
this is the radian references. 92 is a radians. Radians is nothing
inverse
but
cosine,
pi basis.
mm-hmm.
Degrees of a cos. Let's see one example. So cos 90, cos 0. We can compare it. Cos 90, actual value should be 0. Cos 0 should be 1. Let's compare this
Yes.
value. Then we can compare it.
Mm.
If it is correct, then it's correct. I'm right.
Mm.
Cos 90. I'm coming. Somewhere we are
Cos
mistake.
90, yeah.
90 degree. 9, sorry, 0.5. Cos 0, right. 0 between 0 and 1, we have to compare it, right? Then this is the value we have to get it. Correct.
Cos 90 is 0. Okay. Cos 0
Correct.
is 1.
Yeah,
Mm.
you can see this one.
Mm.
This is the value. This is the degree. Okay, I am applying the formula. Cos of 90 should be 0. Am I right?
Correct. Cos
So
90 is
0
0.
is degree. Cos 1, cos 0 should be a 1 value. So this is
Yes.
working for same. I'm going to apply it here. Degrees a cos. This is the formula we have to use it. So now 53 degree, this one. So 53 degree means how much is it? Now let me copy everything together and paste into the
A cos means it is opposite. What is the meaning actually?
inverse
A
cos.
cos. Inverse cos. So, cos 90.
Okay, so this is the formula I'm trying to apply. Now I got the value. It doesn't sit with this. Okay, now what I'm going to see, I got the output 53.13 degree. This is the output I'm getting right now. Yes, my screen is visible.
Yes, yes, yes. Yeah.
Okay. Now I'm going to create a chart. This is the final value we are getting. If I'm going to apply in axis A and B, the similarities 53. So this is 90. This is should be 0. I'm supposed to take this one as a 45. 53 it should come here. This is the B. Okay, this is the differences, the similarities in the vector dimension model. Got it? If it is less, then we will be getting very similar, less than 30 degree should be. Okay. Uh, less than 60 degree modular similar. Moderate similar. Above 60, whatever is unsimilar. Okay. Now this is one. Modular similar. Between A and B, we are getting modular similarities we are getting.
So, for the
Got
same
it?
value, it will be 0.
Which one?
For the same value, it will be 0.
Which
See,
same value?
consider the value of A and B same. What is the output then actually for this?
Modular
Consider
similar is close to the same value. Same meaning.
uh,
Same similar meaning.
then what
So
will be the
that's
value
you
of
are
this
trying to.
cosine similarity for that actually? In the
Yeah.
in the A and B value, I'm trying to understand what is the value of the cosine value, the same.
Yeah, 53 means model and same. So you have a sentence, right? The sentence we are trying to pick
Yes,
it.
yes, yes.
That sentence is 53 degrees close to the same ranges. This is the meaning for that.
Okay.
Sometimes you have different sentences. You're going to find the attention values. So the multi-age attention is going to be run and get the value of the word embedding references. At the time, how it is
Mm,
close to that. So that's
mm,
based on this similarity references only is going to be suggest for you next word.
okay.
Okay. So if example, I'm walking. Okay, this is my word. I'm giving us a token. He is going to be check other words, the next prediction words with this A and B comparisons only. Whichever
Mm,
come to less than 30, that all will be giving us a priority to you. I'm walking on the road. I'm walking near to the park. Different words is available.
okay,
I'm
okay.
walking on the sky.
That road and all similar to that
Every
walking, you are
tokens,
trying to say.
ev-
Okay, okay. Running out. Okay,
exactly.
okay. Got
Every
it.
sentence going to be compare the similarities. Based on
Okay,
this
okay.
cosine
Got
similarities
it.
only, your token going to be suggested next what it is. This is comes as a weighted matrix. In attention layer,
Okay.
you will be getting QKV is a kind of concept. There, this kind of similarity only going to be work for you. Got it?
Yeah.
So these are all the advanced level. I cannot explain you. That's why in the first level concept itself, I just explained all these things.
Mhm. Yeah, that we have. Yes, done. Mm.
Guys, are you clear? Any questions till now? Let me know if you have any queries. Almost 1 hour gone. Sorry. If you of them is watching IPL, I'm so disturbing today. I'm so sorry. Everyone is clear or still confused somewhere? Is it clear for everyone? Oh, I'm sorry. I sharply start because I know today's session is going bit late. That's why. Exact 5 o'clock I just started.
I think we have to understand the basic concept here, not that deep.
That's
Yeah, not that deep. So many things.
no issues,
Yeah.
no issues. So now everyone is clear, right? Any questions? I'm welcoming your questions now. The next concept is very difficult. We cannot go this far. We have to show in the program only. That's why I'm showing the basic references in this chart. Yeah, sure, no problem.
We covered BPE and cosine similarity. These two concepts we covered, right?
Correct. This is the cosine similarity. BPE first topic is covered already.
Yeah, yeah. That's two concepts. Yeah, got it.
Okay, then I can go for the next topic. Third one is embedding model. Actually, I plan to continue only 1 hour. But guys, can I continue or shall we take next week? It's up to your decision. Still now everyone is clear or doubts? Because face word embedding with code level is very difficult. Maybe first I can decide. Next week we can continue. Is it fine for everyone? You also summarize and practice with the trigonometry, matrix multiplications, and dot product references, and much more things. These are the basics for this one. Okay. Then I can drop out now. Next week we can continue with word embedding, positional encoding. Positional encoding is not a big deal. we can easily understand. But word embedding is very, very complicated. If you are understand, I'm very happy because word embedding is going to be playing the big role in the backend for you. There's a kind of token embedding, word embedding, everything's the same. That's converted into the token matrix, and this token matrix is going to be play for you in the backend.
Yeah, I have only one question. Like, so this cosine similarity is calculated for every sentence when you type in, or how is it stored? Like,
It's every word level, not with the sentence level. For example, I'm taking sentence level. Next example, next phase to the next session, I'm going to show with the word level. It's based on multiple dimensions they are going to involve.
mm,
So that's why it's very, very complicated. But now you understand this video, then you can understand bit easier for you.
yeah, it's
Okay.
it's like for
This is
auto
sentence level. We
completion.
have done it.
Yeah, it's
Yeah.
it's for this auto completion, right? Like to suggest the next word.
Auto completion is a part of tries as a concept. That's a
Okay,
different.
okay.
Okay, not this one. Cosine similarity is only for matrix. Embedded matrix only you are going to use it.
No, but
Okay.
what is the where they will use this? Like,
This is the your actually your token you are going to provide it, right? All your tokenization. The backend is going to run this references
okay.
only.
Oh, so it's
So
eternal.
tokenizations exactly. So I will show
Okay.
the examples. How many
Okay.
dimensions for the each word they are going to get it, how they are going to provide it. Some interesting example I may be going to use uh, king minus man plus woman. What is that?
King minus man. No.
King minus man plus woman. If suppose I have a word king, I have
Mhm.
a man, I have a woman. I want to minus this value. I want to add this woman value. Then what will be the answer? So king and plus woman. Who will be?
Queen.
A lady king, queen.
Queen. Yeah,
Yeah.
yeah.
This is the answer you're going to get it. This is the word embedding. Maybe I will show the example in real time how it is working. It's a very famous word embedding.
Mm-hmm.
If you're going to check anywhere in the Google, they will provide you. This is the first example.
So in that case, I'm
You can see this one word to vector.
yeah, we have the database for this actually. Somewhere we'll store all this combination.
Correct.
The input we are
How they are
passing.
stored, how the values are there extracted, how
Yeah,
it's
yeah.
provided into the model. These are all we are going to discuss in the
But
next phase.
actually, see, English is common, right, throughout the world. So if only one person creates it, it can be used. Everybody can use the same dictionary, right? Like kind of internals.
That's why they are using different dimensions because
Mm.
Indian slang is different, UK slang is different. So how their dimension they are going to use it. This is
Mm-hmm.
in that practical manner.
Okay.
Okay, right now we are taking only two dimensions, A and B, two centers we take, and one not encoding we applied and compare the difference between them. That's we have achieved it. Later, what is going to be happen? We are going to see the comparison to multiple dimensions. Almost 768 dimensions available, 1024 dimensions. If you are going to compare the GPT dimensions, GPT-4 dimensions, approximately 12,288 dimensions they are using, and 1.8 trillion parameters they are using it. How is it possible? How each word the cosine similarity is going to be run and provide a very fast output, the parallel way. How they have decided these things. These are all is tricky. Maybe I will try my best to show all of them with practical manner. Okay,
Okay.
that's fine. Right now we are check only two dimensions, x and y axis. We are trying to compare only two sentences as a word reference we have achieved. But the practical is very, very different. Will do my best. Okay. So meanwhile, you guys are practice and let me know. Next, any doubts you have a WhatsApp group, you can ping me. We will discuss further on this. Okay, guys. Is it clear for everyone?
Yes. Yeah.
Mm. Okay. So, and this is my LinkedIn profile. Stay with me in LinkedIn. We can discuss and we can share our referrals and further things. Okay. This is my plans. So we will be communicate together and we will create a better network here and we will be work together in the future. Okay. This is my plan. So we will be work together, practice together, learn together, and do in the better life. Wish you all the best to everyone. Okay, next week same time 5 o'clock we can continue the further topics. Thank you very
Thank
much.
you. Thank you. Thank you all. Thank you. Thank you, Dinesh.
Thank you.
Thank you.
Just provide me your updates or whatever the comments in this video. That will help me to communicate a big group. I am planning to create a group here. That's for your future networks. This is my plan. Okay,
Okay.
share your thought.
Yeah, yeah. I
Thank
will
you.
play for sure. Yeah, sure. I will. Thank you.
Thank you, brother. Sure.
Thank you.
Thank you all. I'm stopping recording now. Screen is visible, right?
Yes.
Good. It's so last week what we have discussed. Can anyone remember? Sometime. So day one session. Last week we discussed about tokenizations, how the input tokens as converted into the tokenization model. We will be see some mathematical example with the byte pair encoding, and then this is how it's working with the vector. Uh, the vector combinations we'll be going to understand about um, cosine similarity, and then we'll be going to discuss something related to the trigonometry level and see some example with the cosine similarity with the one words. We just take one input sentence, input embedding, and we are going to compare with our cosine similarity. What is the ratio value we are getting it? How much? How the differences there? Those two vectors. Example: sentence one, sentence two. So we'll be going to see the comparisons between them. How close together? That's we have verified. So this information last week we had a discussions. Anybody have any queries or doubts in this? This pure mathematical we had a discussion on last week. Okay. If no doubts, then we'll be continue. Today is a day two. Today our plan is we are going to discuss this cosine similarity, how it's going to be worked with word embedding. We are going to see some example with the Python programming and mathematics. Both we are going to see today. Okay. So this word embedding is over. Then we're going to start with positional embedding. Sorry, positional encoding. Okay. So this word embedding plus positional encoding, this is going to be worked with your all your transformers. This transformers will be going to see with the encoder model separate and decoder model separate. And then we'll be going to see multiple attention layers available. Each of the attention, how it is work, we'll be going to see in the backend with the mathematical platform. The overall agenda as of okay. So any questions in this, please ask me. Otherwise, I'll continue with the word I'm running today. Okay. Hope nobody have a doubt. Then I can clear the screen. I will be continuing with word I'm running. So what is word embedding? Great experiment. No issues, sir. We'll discuss. No. So yeah, I will give you the recording. You can refer. So now let me know what is word embedding. What's your thought? Just share with me. Anyone? Because those are the basics. From here only you can integrate with your actual LLM models. Okay, you are providing the sentence, right? Example, you are providing sentence as a token. I am Dinesh. This sentence I am going to pass into the LLM. Okay, so this is I'm going to transfer into the LLM, but unfortunately it doesn't reach directly into the sentence. It will be converted internally into the tokens. So how this token will be converted? This is what we have discussed on last week with the byte parent coding. So subword tokenizations and character level tokenization, how it's split up. Thus we had a discussion. So it will be generating some numbers. So 002, 123, 89, 0 something. The word will be converted to some numbers. This number is not enough to communicate with our environment because it doesn't have any weightage and it doesn't help to make the aggregations with your LLM model. It may have a different thought references. So what they have designed, these values they are going to add with some vector references. That's why we had a discussion last week with the vector, how it is vectors working. So multiple encoding vectors they have designed. That's called as a dimensions. So maybe the people will be saying vector D model, dimension model. In your transform architecture, they will be mentioned D model something. So this is actual each of the word that particular word they will be make it out with a lot of vector references based on some different categories they have done it. Example, I just provided this I what is they are meaning it and what they are trying to mean it. Dinesh. Each word they are going to see some vector categorizations like they are going to see the values based on that gender level and this is related to the grammar check the gender. This is grammar. This is grammar is correct or not. Maybe let's misspell. Okay, so gender and then grammar and this word have a sentence. What kind of sentiment? So sentiment analysis they will be provided as a positive sentiment or negative sentiment, something like that. They will be introducing n number of dimensions with vector basis. So as of now, GPT-2 they are using 768 dimension they will be generated. But as of now, we cannot go this much. I will show some real practical demo at last after the discussion. And we are going to take that actual value and we are going to compromise all the input references to see the actual behavior. That's the plan for the plan for today. For understanding purpose, I'm taking only for 4. And this 4 dimension I'm going to use and do the development. So this 4 dimension is called as the embedding references, word embeddings. Now is it clear? This 4 is nothing but this categorizations. Each tokens, they will make some categorization. This categorization we are calling as a word embed. Is it clear, everyone? Or is confused somewhere? Arul, do you have any questions? Okay. Others? Okay, fine. Now I'm going to show the examples. I'll take one of the famous example for this word embedding. So first one, yeah, right. So king, queen, something. This is the word they will be provide. This word, how they are going to make the embedding one. That's we are trying to discuss. I'll take some examples from we are making very good topics. But they are not providing the arithmetic logic, but no problem. I have that concept. So I'll take this reference as one. King minus man plus woman. So king, but he is not a man, but he must be a woman. Then king must be a she. That's why queen is coming, right? So power wise is equal, but gender wise they are not a man, they are a woman. That is the meaning for that. Are you able to follow me? This is the same we are going to take as a reference, and we are going to see in the
Yes.
back end how vector embeddings work. Okay, great. Okay, so now I'll take the same example. I'm going to see the real output in front of. Okay, I take this example. Now we'll see that what is the value for king, and then what is the value for man, woman, queen, and then we will be trying to aggregate this two, sorry, subtract this two, and add something. So the addition, the subtraction, we have to do that, and then we can see the result. It will provide the outcome close to the queen or not. That's we are going to see in the real time. Okay, that's why last week we have discussed the cosine similarity. So king is a one kind of vector we are going to create. Man is another one vector we are going to create, and then woman is one more vector. If you are going to combine together, then you're getting the output as a queen. How mathematically it's happening? This is what we are planning to discuss today. Got it?
Yes.
Are you ready? Nice.
Yes.
I'm going to. Okay, I'll open Python PyCharm. I don't know why stream is divided. Open my PyCharm. Okay. Okay, so there's a program that I'm using it right now. There's the example for king. I'm just going to be take this values as it is. I don't want to take this one. So glow is a global vector they're using. This is actually they're using for their GPT-2 model. Same, I'm going to take this data set and what the value they are provided for the king, what the value they are providing for the queen, a woman. Each of the values I just extracted one by one right now. So now I'm going to apply these values and I'm trying to compare it. So king, I'm getting this values. I'll take this values as it is. First four I'm taking for the today example because this is have a lot of vector references. They will be based on the categorization they will be designed. Unfortunately, I don't want to take that much. Only four I'm take. Each of the four numerical category vector references I'm going to take. This dimension I'm going to apply to it, and we'll see the output. Okay, I'm taking the Excel because Excel is very easy to communicate. The same output I will run in front of you with programming. And when I must get this result output. Okay, I'm going to split this each word. So green is a final result. This is not necessary. Other four we will take this one, and each of them is like a vectors. This is what you find. Okay, numerical reference. This is what you find. Okay, all of them is working. Now, first word is a king, right? So this is I can mention that this vector is called Vm. This vector I'm calling Vw, and final result I will be getting Vq. So this is minus man plus this aggregation I'm going to output. This is equal out. How this value derived mathematically we are going to see and see the cosine similarities compared. Tell them any questions? Any doubts?
Uh, uh, One question here.
Yes.
So when you say model king, model man, what does exactly, is it actual a model or what? I mean,
No, every token, king is a one token. You can consider it. Man is another one token. But this token will be converted into the word embedding only. For this example, king is how they will be categorized based on the vector of the word embedding. They will be going with a royalty. There is multiple categorization they have applied for this one.
okay,
We must provide this information. Then I have provided. Actually, king, man, woman, and queen. This is based on some human related perspective they have done it. So, what is a king? He must have a royalty, and the king must be a gender of the male, and like multiple categories, they will be divided. Am I right? This is what I'm trying to say right now.
okay.
Yeah, try to
Uh-huh.
go. So each dimension, they will make some values as a vector. Somewhere they will be provided the example, but somewhere they are not provided. Yeah, royalty, monarch. These are all each one of them have a different vector. Like that 768 categories they will be designed. Right now I'm taking only four. Like this GPT-2 model, they are using 768 dimensions. Okay,
Okay,
what kind of category they are? If the male and he is powerful man, then he will be providing high weightage. If it's not a male and he is a woman, then they will be reducing the weightages. So equal that a royalty basis, they have multiple criteria. Based on that only vector is going to be referred in the backend and work together. The same we have reviewed in the cosine similarity last week, and we can see each of the value how it is behaving. So in this example, you can consider first value like a royalty. Yeah, 0.50, coin also 0.37. But just to have a very less value, you can compare it because they don't have any royalty references. Second one must be, I cannot compare it this value, but something like they have multiple categorization, they will be designed like this. So these are all the categories. This categories is a vector they will be designed. Okay. Till now you are clear, right?
Yes, yes.
Maybe I'll check that information. I'll give you this. Okay. Right now, what I'm trying to do, this vector, because vector have multiple values, I'm trying to convert, using it. Same like this vectorization, I'm going to use it. Each one of them is a different vectors is going to be communicated. Okay. Now I'm going to tell now any other question, guys, because you feel this is very easy, but hereafter you're going to work with mathematical. So let me know if you have any questions.
So vector represents a vector on the graph itself that we call it.
Yeah, correct. So in this vector, how it is behaved, you may consider. Okay, so maybe this is one axis, this is another one axis. VK, you'll be going to use it. This is VK1, might be 0.50. Example I'm saying. Okay, another one vector is going to be bigger. 0.68 is a VK2 minus this value minus 0.5. Then it should be this way. This is king third vector. Another one is minus 0.02. It's like this one, it will come minus 0.02. VK4. Like this, there's a one vector. For just a king, they'll be using 768, like I said before. So single environment, multiple vector will be combined together and provide the meaning for this king. Same like man have another one vector references. Man have 0.09. So it should be in this way. Could use another color. Minus 0.09. This is the vector for man 1. Same like each of the value you can design it. Multiple dimension I cannot. For your understanding, I'm showing the two-dimensional vector model. Okay, now you got it right.
Yes, understood.
Others, are you clear now? Okay. What about others? Okay, great. It's not a VS Code. I'm using PyCharm, Ganesh. I'll show the example output in the Python programming later. First, we will be understand the mathematical. Okay. Any other question, guys? Okay, fine. I'll continue. Now let me going to compare these values together.
Hello.
Yes,
Actually, I missed last session. So, is there any link between this and last session? Like, I mean,
exactly. Because cosine similarity and embedding, that's we have discussed in last week's session. So that's we are going to apply today and we'll see the output. That's actual plan.
okay, okay.
Okay. So we'll see the comparisons output. Maybe I'll make it to
One
the
question.
simplified. Yeah.
So when we categorize it, okay. So so for example, if somebody put that word in text and submit it, it
Hmm.
compares the predefined values to it. Like,
That's how you're designing your LLM model. There you're going to fade that inputs because multiple category segmentation is available. If you are going to use the existing one, that is also multiple deviations is available. Because GPT-2 only 768, GPT-3 they are going to use for the 10,286 something embedding sizes.
so
Maybe
these
I'll Google
categories
it.
are predefined, right?
Yeah, but I'll show that example. You can see this 124 million parameter they are using is 768 dimension. Medium size 1024, large GPT-2 1280, and this is 1600 dimensions. That we're going to see with 4, for example. So 3000 dimension they are going to stick to them. Text embedding 3 large model, they are using 3072 dimension, they are using it. And the high end, if you have very good optimized references, the token will be adopted with 12,288 dimension. So if you're going to run your model with this high end LLM, this dimension will take more computation power and provide the more accurate output to compare with the tools. Okay, because 768 dimension, he might provide less accuracy, but if you're going to use 12,288 dimension, then it will be give you more accuracy in this. Okay, like that the
Okay.
predefined is available. While you're going to create your own LLM model, this is you can design it based on your GPU references, how that the we'll be calling as a flops references. Based on we can calculate this much, how much will be capable with your framework. That's we can achieve. Maybe at last session I will be plan to create with one SLM small language model in front of you, how it's going to be designed and how we are going to see the responses. Everything I planned. Okay, we will see the
Okay.
example later.
Yeah.
But the
Sure.
concept.
Yeah.
Concept
Yeah.
wise,
Got
everyone
it.
is clear. Anybody have any queries, doubts? Okay. Others? Okay, fine. So now I'm going to take this output. I make very small vector because a few of them doesn't know about the similarities. I don't want to take this vector as separate. Maybe I'll take a result vector separate. What is the result vector for this output? And then I'm trying to compare with that actual output we are received from the Python program. This is what we are getting from the Python. This is Python. This is Python. We are getting from the embedding model based on global vector. That's the meaning. So we are get that embedding value from them. Now I'm going to compute these values and to create my result. This result, if it is going to be matched with this vector coin, then this is enough for us. I'm trying to compare only this cosine similarity between these two. Then we'll see the total output. Okay. Now what I'm trying to do, I'm going to add this value and subtract this value plus add this value. Okay. So this is my output 0.41 I'm getting for one embedding vector references. Same like all four, I'm going to get it right. Is it clear? Everyone is clear? Are you in the same point?
Sorry. How did we arrive to those values?
Just I'm going to add the value and remove it. This is additions.
Oh, okay.
So king minus man plus woman. Same I'm doing. King plus man minus woman.
Got it.
Okay. Everyone is clear? What about this? but which is a little bit complicated. That's why I'm trying to shrink and will try to show you with the basic level. Okay, now we are going to see with the cosine similarity that's we have discussed in the last week. Maybe I will give you overview what is happening with cosine similarity. 1 second. Okay, how dot product works, how cross product works, how cosine similarity help us to get the accurate output for us. That's I would like to recall for today's session to 5 minutes, and then I will show the output page. Okay. Any other question, guys? That's why I requested to join you all the classes. Then you can easily understand the mathematics flow. Because Python programming nowadays you can Google it, you can get it because it's outsourced. But actually, what is happening in the backend that you must know as a AI engineer. Otherwise, it's very very difficult while you're going to debugging and providing the better solutions. Because AI is promote and do all your activities nowadays. You want to be more smart than AI. Then you must know the algorithm backend. What is happening? Am I right? Is it clear? Shall I go next?
Yes, yes.
Okay, fine. So now, simple. This is the one vector you can compare it. All these values will be get as a one vector embedding, and this is our result actual output we are getting from the Python. I'm trying to compare this to with the cosine similarity and will show the output. I don't want to confuse with you. This is make me. I can explain you, but it will difficult to understand from your end. So what I'm trying to do, I'm take these values and try to compare it. How much similar between these two vectors. So based on we can take the decision. Okay. So now I would like to recap what is cosine similarity. What is the meaning for cosine similarity? Last class, those who joined, I said why it is cosine, not for sine. This is also I explained. Cosine similarity, why we are using it, and dot product, cross product. This all we had a discussions on last week. I hope so. Anybody can remember what it is? Anyone? Welcoming for your answer. If anybody recall it. I expect someone will be preferred and practice it. Okay, fine. Sorry. Now I would like to explain what is cosine similarity. Those who work with AI model, at least mathematical, you must have this experience. We have a two vector, how it is equal and sorry, how it is close together. That's you want to see this one. Maybe we can take this result. Okay, this is the result. I'm getting this result in this one, 0.47, something I can get it. 0.417. Okay, Q might be 0.37. 0.1, 0.2, 0.3. Okay, I will be going to see this one like this. This is the output for your view Q. So something 0.37, it will be transferred from me. Okay. Now I want to know how much close together. What is the angle it is close? This theta references, I'm going to compare it. I'm going to find the value. This value will help us to identify how it's close each other. If it is very close, you can see the value like this. it might be. If it is very close, then it will become to this way. If it is very far, then it will be going to the perpendicular. So a ML model LLM is going to be take this two vector and try to compare this value, and based on this only it can understand how it's close together. The coin and vector coin and vector result, how it is close to each other. That's it will be calculated. Okay, based on that, LLM model can understand this word is very close to this one. Result, I'm getting this one. This is also maybe Prince.
So, uh, is it the
Prince or
case
something.
like it should always be the minimum?
Sorry, come again. Why is this break?
Is it the case where it should always be the minimum degree angle?
Yes, exactly. How it is close. If it is crossed this way, then what is the meaning?
Okay.
You have this much, then it's not a same similarity. It's a different similar. Maybe the man word will be have a different similarity to compare with your princess or queen output because it doesn't have a same meaning. Queen here, but man here. So it's not close together. Okay, if it is very close, then you can see the output nearby here. Got it?
Okay. Got it.
Okay, so this is what we are going to see with output in the practical view. That's the plan today. Any question till now? What if the line is 270 degree? 270 means where it comes. This is 180. This is 90. I'm going to take this one. 270. Again back to 360 here. This is quad 1. This is quad 2. This is quad 3. This is quad 4. Start with 0, 90 degree, 180 degree, 270 degree, 360 degree. If the line is 270 degree, then it doesn't have a close together. That's completely negative meaning. If it is between 0 to 90, then it should be close together and the meaning will be positive as a close together. If it is in the reverse in 270 degree, then it's a negative, completely opposite meaning. That's the meaning for that. Okay. I will hope I answer your question. Okay, fine. Now I'll take this values and trying to compare and see the output now. So result I already collected. Now I want to apply the cosine similarity formula. Cosine similarity is a dot product or cross product. Is it dot product or cross product? It's a dot product. You can see the dot. But actual cosine similarity is a dot product. If it is cross, then you will be seeing this one as a cross. For formula level, I just explained, but actual meaning is different. Dot product help to see the comparisons between two vectors. That's the useful for your dot products. Cross product, how it's the parallel directions, because one vector go in this way and another one vector will be going this way. If both will be met together in the parallel flow, what is the value for them? That's we can calculate just on the cross product. So I don't want to confuse you. As of now, you can understand with the dot product. Dot product will help to compare two vector how it's close each together. If it is close, then you will be seeing this way. If it is far, you can see this output in the different way. Like this, the vector deviation is going to be happening. Now I'm going to apply this value here. and we'll see the response. This is my plan. So this is below is an inverse, above one is a dot product reference system. Okay, I can consider P result is of A, this V queen result is of B. Now I'm going to compare this two and we'll see the output. Got it? Now is it clear, everyone? Is it clear, everyone? Okay. So now I take this one, first A dot B, I'm trying to compare it. For that, I want to convert the directions because matrix multiplication will not be directly, will be combined. We have to transpose the value because this is the value for 4 is to 1. So 4 is to 1 and 4 is to 1 is not possible. So you want to change the value from here to 4 is to 1, 4 is to 1. You cannot multiply both. So what you can do, you want to transpose this one, 1 into 4, then 4 is to 1, then this is both will be the same, then you will be getting output 1 is to 1. So 1 cross 2. Okay. That's why I just transpose this value from 4 is to 1 to 1 is to 4. Now it's 1 row, 4 columns. Now VQ I'm going to apply and we'll see the output. From Excel formula, matrix multiplications 1 is to 4, comma 4 is to 1. If you're going to connect, then you're getting the output. So this is nothing but it's going to be apply the matrix multiplication, the backend for you, which means 0.41 into 0.37 plus 0.90 into 1.82. Same like addition is going to be each of the word is going to be added here. This value plus this value multiplied value, this value multiplies and this value multiplies. Okay, there's a matrix multiplication output you are getting it. So dot A dot B value you are getting 3.08. Are you able to follow me? Others? Ganesh, Bharat, Kamaraj.
Trying to understand.
This is A dot B I'm trying to apply. A dot B is nothing but matrix multiplication. I'm going to do that. 4 is to 1 vector, 4 is to 1. So you can consider as a matrix 4 rows,
So
1
when you
column,
say
4
4,
rows, 1 column.
oh, okay, matrix multiplication.
Yeah, that's what I'm doing. So 4 rows, 1 column, 4 rows, 1 column. There is no chance to directly multiply this one because the base is not same. This one is not same. It should be same, then only you can do this calculations between them. Am I right? This is a common logic for your matrix. So what I can do, 1 is to 4. I'm going to replace this value into 1 is to 4 and 4 is to 1. Now both are same. Then 1 is to 1 output. I'm getting the scalar value. This is I'm doing here.
Okay.
Now you follow me?
Yes, but I still need to go through this. I mean,
No
I
problem.
understood the concept, but the
Mm.
actual calculation that I need to,
No problem. No problem. Take your time.
view your,
Okay.
yeah.
No problem.
So it's
Recall the
been,
previous
I
session.
was in school
You
when
get
I saw, when I learned this cos and all.
people are doing a nowadays is a completely different way. They are trying to focus with the coding, but actual coding is outsourced. Nobody looking for the coding nowadays because AI will be
Mhm,
generated. You
mhm.
want to deal with the coding, but you want to do that fine tuning model. You want to understand the backend. Then we must know that
Mhm.
mathematics. That's very important. We don't have other option. Frankly, I'm saying.
Yes. Yeah,
Okay.
totally.
So now I got the value for A dot B vector output. This is the dot product. I'm getting the value 3.08. Tell them everyone is clear. Let me know if you have any questions. No question. I'm very happy then. Okay. So this value I'll be making this one. Now inverse of A, inverse of B. This is I want to calculate. Why I need to do this? What is the purpose of inverse? So dot
Inverse
product
will
you got
have
it.
negative value.
No, not that inverse. In vector inverse is nothing but how that direction is going. How much the length for the direction. That's for inverse here. They'll be providing another one name. I forget actually. So this is one direction is going on this way, right? Vector 1 is going this way. Vector 2 is going on this way. Both are in the same magnitude, then no issues. If I have a different, then how much deviations? I want to calculate based on the sine. Okay, this is in your trigonometry. This is opposite. This is adjacent. This is hypotenuse. So I want to find this value. Then I want the opposite divided by adjacent. I want to apply. Then tan will provide this output. But already I know that direction is going on this way. I because these are the value of this each of the vector references will I'm getting it. So how much each of them is going on the run parallel? That's I want to calculate. That is the meaning for inverse here. You're trying to
Okay.
catch me?
Yes.
Mm. It's a bit difficult. Maybe recall the sessions. It will definitely help you. Okay. Okay. Now I'm going to continue. Now I'm going to say that inverse of this values. A inverse, how much? B inverse, how much is it? I'll take this value and down. Okay. What is this? Okay. Okay. So inverse is nothing but a square root of each values based on the trigonometry. The Pythagoras theorem says right something. Hope you remember the Pythagoras theorem. If you want to find this value, opposite and adjacent square root, then you have to take the root. Square of opposite plus adjacent, you want to take this. Okay. That's the meaning for your hypotenuse. Just to recall your 10th mathematics Pythagoras theorem. The same I'm going to apply here. Okay. Pythagoras theorem. For your reference, I'm saying because why I'm doing this way. This is the backend reference. Now the same, I'm going to calculate each of the value with the root square values, and then I'm trying to apply it. Okay. This is the value I'm getting. Power 2, am I right? Is correct. So there's a square value, same like I'm going to apply for 3. Now this total sum I want to apply with a root. So square I'm getting 2.0. Now I'm going to apply SQ what is square root of 2.0 now. So 1.41 I'm getting the value for V result. Same right, I'm going to apply here. I'm going to apply the square root for this one, 2.25. So I got the output. This is called inverse of V, or same like the cosine similarity I said, inverse of A and B. Maybe I will give you as a A itself. This is the output for the inverse B output. Now I want to calculate everything together. So this is the value I got, and this is the value I'm getting as an inverse, and this is the value I'm getting as another one inverse. Now everything together I want to apply, and we will see some output. Now only I'm going to apply cosine similarity. Okay. Each of the value I will bring in the down. And I'll do one thing. I'll use this reference. Okay, I got all the value. Now I'm going to apply this formula. And then I want to apply cos theta. Final output I want to apply with the cos theta. So A dot B divided by, are you coming to say no? Normal is not, we are calling as a inverse. Maybe another one name I forgot it. Maybe I'll check and let you know the WhatsApp. Okay, it's very beautiful name, the mathematic. Cannot remember it immediately. I'll let you know also. Okay, I would like to apply this value. Okay, 0.96. What is the meaning? What is it? Entire formula you applied 0.96, you got it. But actually, this is not a degree, it's a radian value. This output I am going to apply in cos theta, because cosine similarity equal to cos of theta that you are going to apply on your output. So this output I am going to apply with cos theta, and we'll see the output. An Excel formula is called a cos and this value. So which means 0.259, which means 0.26 means 14.89. So this is, you're getting that radiance output, because it's a scalar value. 0.96 is a scalar value. You're going to apply, then you're getting that radiance value. Radiance is nothing but trigonometry have a radians and degrees. Radiance is nothing but everything will come with a pi basis, pi by 2, pi by 4, something. Degrees will give you from 0 to 360 degree. So that's why I'm converting from pi radians to degrees. That's why I use this formula. Are you able to follow me? Everyone? Others? Are you clear, guys? Or still confused? Ganesh, Kamraj, Ram, Venkat.
Sinking in.
The same I have done in the last class. But for you, I just very strength the topic and will show you the direct output here. So this 14.89 is nothing but close to 15 degree, because I applied degrees of your radiance output. 15 degree, which means what it is trying to say. I have a value as a V queen. I got the output from our Python. I want to apply that. I want to compare with this, whatever I am applying with the cosine similarity output VR result. So VR result is nothing but 15-degree means it's very close. Like this. Okay. This is 15-degree. 14.89, I just convert into 15-degree. So if it is available in this way, it should be a 45. Then this way, it should be a 30, 45, 60, 90. Okay, multiple direction we can compare it. Now I take only one 15-degree for your vector. So both are very close. So this word and this word is equal. That's the meaning I'm getting it. This vector result, whatever I'm getting, this will give you as a princess or any other name for queen. Anything is available. Can you remember? Or we can call as a Rani. A Rani and queen is close each other. This is the meaning for your cosine
So,
similarity will produce the output.
so princess is another category that we have or dimension.
Exactly. For understanding purpose, I just take it. I cannot remember the equal word for the queen. The word have a different, same word is available there.
Okay.
So I cannot remember it. So for understanding purpose, I just take this value. We consider as a Rani. Mostly Rani we can use it like Maharaj, Rani,
Mm-hmm.
something. So
Uh-huh.
you can consider it. Rani and queen is close. The both word is close together. That's the meaning I'm getting. Because 15-degree only, both vector is available. So it's very, very close. If I'm going to take Raja, if I'm going to compare this value based on the vector result, it must come this way. It's not close together. 90, maybe 170 or 140-degree, completely opposite. Okay. So we are getting the output very close together. Based on that, whatever we are getting the input. I try to apply the input directly and will show the output to you. Am I right?
Yeah. Yes.
Yeah. It is close to 1. 1 means what you're trying to say, Arun?
Any standard how much is to be close to be precise?
It's not like that. It's less than 30 is very close similarity. If it is greater than 30 to 60, it's a mid-level. Above 90 is unsimilar. That's the only meaning. Okay. So close similar, modular, or unsimilar. Based on
Okay.
that, your transformer LLM model can understand what is happening behind. Theta value is close to 1, then it will become this big. Yeah. How much very close? Then your direction will be in very close together. If it is both have the same value, if you are going to apply this one, example, V queen, if you are going to apply with V queen again, you will be getting similarity 0. 0 means you are getting 1 output. So which because both are the same similar. If you take assignment, VQ value and VQ value you can apply together and you can see the output. It should be in 0 because there is no differences. Both will be the same similar. Okay, you can do the practices. If it is completely different, if you're going to take the value king and you're trying to compare with the queen, maybe it will be crossed more than 45 above. Or if you're going to take the value of queen and man, if you're going to apply the dot product here, then this is completely weird output. It should not be in the match together. It will be provided the output in a different way. This is going to happen. Got it?
Yes.
Any question? So everyone is clear now, right?
Yes.
Just a simple example. I'm going to run in front of you and we'll see that. Okay, so glow, I'm trying to use it. I take the king value, king minus woman. We want to confuse you directly. I'll go to the output. Yeah, there's them. So you can see this model dot most similar. I'm trying to apply king positive. King and woman is a positive, negative man. So king plus woman minus man. What I'm getting output? Coin. It's very close, 0.85. What we are getting the output right now in the Excel? 0.96. Okay. If it is a throne, then 0.76 similarity radians we are getting it. So we are going to convert this value into degrees. We will be getting actual theta values. Okay. Now you got the output right. What's that? Are you able to follow me?
Yes.
Same like Paris, Germany, and they are removing the France. Then what will be the output? Berlin is a very close one because it's going to be apply all the competitions with their vector values and we'll try to compare the output with Berlin is very close. Same like hospital teacher doctor, they'll be getting as a score. Because in hospital, if the teacher is available, then that hospital is like a school only. Okay, that's the meaning for that. So this is word level embedding we are trying to do that. Actual, this entire word will be create as a sentence, then we'll be calling that one as a context. So semantic context, we are going to see the output in the later, but it's very difficult to understand. That's why we are taking the word level embedding right now. Okay, even this is little bit complex for you. Do practice is very useful for you, I'm sure. Now you got the point, right?
Yes.
So this is you are trying to see into it. Okay, the same output. We are work with the mathematically. We are trying to compare and see the output. It will provide with a 0.85, and why we are getting 0.96. What is the reason behind it? Can anyone tell me? What would be the reason? Why we are getting 0.85? Sorry, 0.96 instead of 0.85. Can anyone guess?
I think we didn't take all the dimensions.
Exactly. So
Maybe.
dimension only we are take 4, but they are using 768 dimensions. Okay, if supposed to apply 768 dimension, it should be the same output. 0.85 only you're getting because multiple dimension will be involved, will not be getting close accuracy. So 0.85 is more enough for us. Okay, now you're coming to the point. Okay, guys. I hope today you have some clarity what's happening. Let me know if you have any queries or doubts.
Thank you, Dinesh. I mean,
Okay,
actually, I've been, you know, the mathematics I was lacking. What how that works actually, be, uh, behind the uh, program or logic. So this is very helpful.
actually, I'm starting only for you, so just 10% maximum saying. We have a lot of things
Yeah, I understand.
algorithms available. So we have to practice and we have to work together. But once you enter, then this will help you. It will increase your curiosity. What is happening in the backend? Then you can easily understand with the programming was. if you are going to create your own LLM model, you may be struggling a lot because only you are trust with the code. You don't know the backend behavior. You cannot optimize the code. You cannot provide a better output because optimization very
Okay.
important. Number of token, if you are ready to use it, and cost will be in save for your company. That's is going to be helping. Am I right? So blindly we
Yes.
cannot work with the LLMs. Everything is a cost
Mhm.
basis they are doing it. So how we are going to deep dive and we are going to reduce the cost. That all will work with them the mathematical way only. We have to calculate with
Okay.
processor level how much bytes we are spending for each token, how much the cost will be compared, what is the probability reduce it. This one we have to work to.
Yeah. So it's a beginning journey for me. Uh,
Yeah, you got some heads up now. So no, that's I'm very happy for that. Just focus in this way instead of coding, because you just go on Google,
any
the Gemini, it will be provide the code. I'm sure.
yeah. Any book you want to suggest on this?
Some of the MIT book is available, but a little bit complex. I maybe share the book to you. Okay, I'll share the WhatsApp group, but it's
Okay.
bit, yeah, even for me, it's a little bit complicated, but it's very much helpful for us. Okay, I'll share the books.
Yes. Sure. No problem. Yeah.
Okay.
Thank you.
There is no specific syllabus, Arun. This is completely. I'm trying to discuss and recall my thoughts. That's it. Because I'm working with the LLM, so whatever I have knowledge, I would like to share you. That will help me to retune myself, and I can speed up my work. That's the main motive. Okay. Next week I'll continue with the positional encoding, and then I'll go with the transformers, encoder, and attention layers, multi-attention, blah blah blah. A lot of things is available. How it is working, that will be active.
Yeah. Thank you.
Okay, guys. Have a nice day. So hope it was a wonderful session for you. Thank you all. So day one session, byte pair encoding, we had a discussions, and then cosine similarity, and then word embedding, vector. In vector, we'll be discussing about dot product, cross product. This is what we had discussed. And then what else we had discussions? Tokenizations. The tokenizations and byte pair encoding on the same topic. Okay. So those are all we had a discussions already. So in future classes, today we'll be going to discuss about positional encoding. Once positional encoding is over, then we'll be going to discuss about attention layer. This attention layer we'll be going to discuss about the single attention, multi-attention, and the mask. So during this attention layer, you must know that algorithm, the backend, what is happening with the softmax functions, and then sigmoid and gradient descent, and then we'll be going to discuss related to back propagations, forward feed, back propagation and backward feed is close to the same, and then layer normalizations. I'll mention here. Layer normalization, and then we're going to see with residual. Okay, so these are the mathematical topics. Once we have discussed all this topic on upcoming session, and then we'll be going to continue and do some practices with create small language models, your own SLM. So this is completely Python, but you must know the mathematical behavior. That's we are planning to discuss. Once you have discussed this one, then we will be planning to do something with the Android deployment and the performance with the quantizations, KV caches, and much more things is available. What are the priority? That's I would like to discuss with you. This is the as of now agenda. This is one for GPT. As of now, I'm discussing everything with the GPT architecture model. Because attention, all your need is completely related to the GPT architecture. So that's we are trying to discuss. Everything is done. I would like to continue the session with another LLM model with a DeepSeek. Gwen, and much more things is available. Gemma something. So these all is look like similar to GPT, but there is some changes available. We are going to discuss what is happening because attention is going to be different each of them, and the behavior, that LLM model behavior is a bit different. So each of them we are planning to discuss end to end. The agenda. Hope some idea, right? What we are going to cover. This is already completed. We are going to continue from here only as well. These are also already completed. Okay, why I am preferring with the mathematical coding is not at all useful because it's outsourced. You can just Google it, you will get the coding, but you must understand what it is, how we are going to tune it. That's very very important. So don't waste your time for the coding. You just go and Google it. Google will give you the code. 100% I'm sure. Completely coding is outsourced, and in the future they're going to do optimized way. So we are going to discuss everything in the designing platform, the mathematical way, and then we are going to connect with the Python programming. How it's going to be react with the Python. That's the plan. Hope you got idea, right? Anybody have any questions?
Quick question. This is more about building the SLM and
Yeah.
concepts behind the LLMs. Would you be covering how you would be hosting these things in production? Like,
Yeah,
how would
that's
you?
a second.
In,
100% because this is a deployment, how it's happening, the performance, everything you know. Then we are going to the small LLM, right? I'm going to deploy in front of you and to see some progress with the H10, H100 GPU. So I have H100 GPUs available. I already purchased in that Google. So maybe I'm going to show you real time examples how it's performance wise and distributed by. First, we'll be going to discuss everything in that mathematical and architecture behavior. After that, we are planning to go everything with the agentic model and vector databases, RAG pipelines, a lot of things is available. We are going to see in the deployment phases later. But you must understand these things is very, very important.
okay, thank you.
Okay? Because designing is a second. First, we will understand the concept. Once concept is over, then designing will be go forward. Got it? And
Sure.
multiple tools is available. Llama Index, Llama is a LangGraph, LangChains, and multiple tools is available. That all is a kind of behavior. So that's we are going to discuss it. And with the key values top K, top P, something is available. That's also we are going to discuss. So how you are going to tune your model? How fastly it will be producing the output? Because you are going to submit your LLM model. Maybe it asks for 1 million requests per second. But unfortunately, your model is going to be down. What is the algorithm in the beginning? How we are going to optimize it? How we are going to deploy in real time? What is the actual reality? Because we will be getting multiple requests from multiple region as well. how we are going to be make with a safeguard, guardrail something. That all we are going to say in the later session. But before reaching to that, we must understand what it is. Got it? Any other questions?
Dinesh,
Just close that left, please. It will expand the screen.
What is
That
that?
all tools bar on the left.
This one.
Yeah, just close it. Yeah, thank you.
Okay. Yeah, sorry. Please go ahead.
hey, Maruti here. Just in the first class I'm attending, yeah.
Okay.
So just maybe you can correct my understanding. This LLM, okay, SLA, LLM model, or whatever the model, right? So where exactly currently using in real time? Because of in nature of in my okay, organization also they are using Copilot, Git, GitHub, Copilot, everything. Okay. In the Copilot, whatever is model of chat GPT or whatever you can integrate it with that. For
Yeah.
what now? What is the real time? So where exactly is going to use? Can you, yeah, you already explained. Yeah, just I want to know that. Okay, exactly in real time, this kind of model where we need to build, or already in some real cases use, or wherever is possible we can use that kind. Do you have any idea, please? Yeah, share in now or later
Yeah,
also fine. Yeah.
exactly. Nice questions too. Actually, you are using the wrapper model of LLM, Copilot, or Gemini, whatever they are providing the access. You are going to open it and do some coding. That's it. Your research, your purpose, you're doing it. But reality, it's going to be understand your data behavior. Each business have a different behavior is available. So the LLM is going to be react based on your behavior. Example, I would like to say about your customer offers. You'll be you have, I'm working in the banking sector. I am planning to provide some offers to the customer. I want to know what kind of transaction behavior they have done it. And based on that transaction, I would like to provide some offer for them. So maybe in the personal loan or some home loan, something, the percentage wise I can deviate it. Previously, it's completely in rule based. If the customer met this amount, this much amount, automatically we will be providing the loans for them because automatically they are eligible. But people are doing some fraud. We must know who are actually using it properly, who are not using it. Everything we can track based on our LLM and based on their behavior too. We cannot connect apart from our banking network. Now we can connect with middleware services. We can fetch at real time their CIBIL score something like, and we can compare it to what they are doing. And based on that, LLM will decide and producing the output. And during this time, we cannot get the generic data. It should be structurized and it should be providing the proper as per our business data set. So we'll be going to fine tune our model and connect with them and sync in that customer based on the messages, WhatsApp or chatbot. A lot of things they'll be introducing it. This will be indirectly we're going to find and make our precisions to our business and making curious to our customers too. So both is happening. There's a one side of example I would like to say. Something like much more things is available. And whenever you're going to use in real time with the LLM model, it's going to be act like a human. So that's the agentic AI model they have introduced it. So this agentic AI, whatever you're providing the input, it just understand and just going to be work with the LLM. LLM just a brain. But agentic is like a based on your structures, is like your body. So based on your LLM comments, agentic AI is going to be checked each of the requested and work accordingly based on customer requirement. So we can increase our profit. We can do best way to continue automations, everything together. That's the advantage for our LLM. That is the main reason all the companies are moving to the LLM nowadays. Some of them creating their own LLM model. Some of them they are using as a wrapper layer. As an end user, business BA or project manager, they you may be going to use only the wrapper, Copilot or Gemini or ChatGPT something only. But in the developer point of view, they are going to be work with the data. They are going to feed the data to the model, and they are going to check the precision, and then they are going for the deployment, mobile chat or something like they are doing.
Hello, Dinesh. Yeah, hi. Dinesh, yes, is this LLM is the only one option or we have any other models to support? I'm a project manager, so I would like to understand more. Like it, you are mentioning that it's a wrapper kind of. But as a project manager, I'll not be able to understand LLM working in background, right?
LLM just a concept. We are using
Okay.
GPT is a kind of one of the LLM. DeepSeek one of the LLM. Quen, Gemma, and the BERT model. These are also LLM. So this is the architecture. Maybe I can clear my screen.
Sorry, I missed the initial part.
No problem, no problem. This is the architecture. This architecture is LLM. How it's going to be read your query based on the text and how it's going to be behave the output. That's actual LLM. But each of the domain and each of the people, we have multiple research developers available. They are creating different LLM model based on the accuracy and based on the different data sets as well. So like a Mistral LLM is available. Mistral is completely for financial related. Something like they are creating n number of LLM model, they are feeding it with n number of parameters and it's going to be work in the generic way. So GPT-3, 4 or Gemini, this all they are creating with the generic format. It will be support for all your queries, whatever, whether it is related to the business domain or is related to any literature domain, everything will be provided. But some of the LLM model, they are only feed for the domain basis only. So that's we'll be creating a different LLM. We are going to feed the LLM based on our business requirement. Because generic LLM have a 200 GB, 300 GB model. It's a big, huge size. As a project manager, you cannot feed and you can complete your development. And your delivery will making a lot of fine tuning and it's going to be making delays. So they will be segregated based on size, value, and parameter based. How we are going to efficiently use the particular LLM and providing the better outcome to our business. That's why they'll be segregated. Some of them open sources, some of them is closed sources. But nowadays, open source is very close to source as well. The concept is called a MMUL, multi-model something they will be mentioned it. If you're going to check the benchmark, you can understand this much. MMLU. So this is the model, how the model is working. So closed and open source, everything they'll be trying to connect together and the accuracy, how it's increasing. So flops and these are all like advanced concept. Maybe fine tuning time. I'd like to tell you what is flops, TTF of time to first token, and a lot of things is available. Influence related. That's will be discussed. But as of now, there's a simple understanding how LLM is going to be divided and it is going to be bigger based on your business requirement.
So behind every agentic AI, and these are the models working. LLM are the models, I believe.
Yeah, exactly. So you see the
And
size,
this
accuracy.
MMLU is the advanced level. Is it the advanced one? Advanced version of the LLM?
No, MMLU is a kind of validation. They will be trying to provide multitask to the LLM model and how it is behave. That's what we're going to see this one. So between open and closed source, we are going to see here that I don't have any clear chart. Maybe
Dinesh,
once I get, I will share in our group. You can see that information.
Dinesh Edward here.
Thank you, Dinesh. Thank you. Thank you very much.
Yeah, thank you. Hi. Yeah, this
Hi
one.
Dinesh.
Yeah, tell me, sir.
Dinesh,
Edward.
yes, Edward.
Hi, Edward.
How are you, Dinesh?
I'm doing good, brother. How are you? After seeing
Yeah, yeah. So, can I answer their question if you don't mind, Dinesh?
no problem. Please go ahead.
So I think Marudu, right? Marudu and someone. So,
Yeah, yeah,
so
yeah.
whatever Dinesh is saying, so behind every LLM or every SLM, so basic algorithm is transformers. So based on the transformers, everything has been built. So that's the only thing. So so how will you compare with Copilot and transformer here? So consider so now whatever you are using Copilot and Gemini or anything. So when Dinesh says it's a wrapper, so you are making some API calls to the particular model. So they will be wrapping up and they will be providing APIs not only for Copilot, even if you call AWS Bedrock or Azure ML services or Azure anything, so you would be calling the API. So and you would be getting some results out of it. So that's how every agent AI and everything is happening. But there are some scenarios where there are some clients they don't need they are so concerned about the data privacy. So when data privacy comes, they even though use call the API, call the AI services, AI services using API. So they want to make sure that it has been masked and sent to the particular Bedrock LLM model, Bedrock or any other Azure services LLM model. So that's where the creating own LLM would be own LLM or SLM could be primary factor. For example, I'm working for a life science clients where the clinical data is so concerned. So they don't they every client wants to deploy their own model in their own premises. So that so you can use Copilot or Cloud or any LLM services. You have to deploy their own model in their premises. So that's where so whatever this is going to cover comes into play. So so when you try to deploy the own model, there are several factors involved. So if you go for a bigger model, reasoning would be good, but the other problem is so you have to spend RAM around 500 GB and the VRAM this GPU would be around 200 GB based on the model. So this is the minimum one.
Yeah.
If you go for 70 billion, so then you have to use some concepts like quantization. Then you have to use some there is a infrastructure VLLM concepts you have to use to make sure that even if you try to reduce the model, so the accuracy is not impacted. So the whatever Dinesh is going to cover is more about deploying own LLM in your own premises and how to make it workable. So and that's a concept. If you work for so if you are using 70 billion LLM model, more like if you consider you are using AWS Bedrock, the downside is if you go more the LLM model, the reasoning would be taking time. So latency would be you would be getting latency around 20 to 30 seconds. You cannot control it because they have deployed in such a format. You cannot control latency or anything. There's a concept called throughput. So these
That's to discuss later. Maybe they will confuse it. As of now, whatever advertiser said is correct. You can
Yeah,
see
yeah,
this one.
understood.
We have using multiple model. You can refer it. How it's going to be. Some of them are open source. Some of them are closed source. We are using it. How the behavior. But our
Yeah,
topic,
yeah.
we are going to create our custom LLM. That's the plan. You are
Got
going to
it, got
create
it.
your own LLM model. These are also open source model. They are feeding with the multiple parameters. But based on your input, how your model LLM going to be react based on your own data set. That's our plan to
Correct.
discuss much. Okay.
Understood. But only one question, Dinesh, what you are saying, right? Please correct my
That will
understanding. So the
that will
LLM
help.
going to use the data is a structured way. That's mandatory, or otherwise
No,
to
no, not
API
really.
service also you would call and get that related data. This kind of facilitate or functionality will
No,
be
all the data going to be converted into tokenization only. So token is not part of your structured data. You're going to make all your data based on your tokenizations. It's a kind of word only. So how this tokenization working already we had a discussion. So word, subword, so subword tokenization and much more things is available as of now. Based on the tokenization only, just going to be behavior.
okay,
Okay, it's
okay,
not a
okay. That's
structured way.
okay.
Okay.
Oh, okay, fine then. That's fine.
Okay.
Yeah.
We are running out of
Thank you,
time.
thank you,
Is
thank
it
you.
tokenization means the prompt engineering you meant, or is it different?
Tokenization, the backend prompt engineering, but as a data is a kind of how we are going to provide a vocabulary as a word, the word embedding.
Okay.
That's we are discussed. Okay,
Okay.
so prompt
Hmm.
engineering, all their query going to be work in the backend based on tokenizations only. But it's a front end layer. The backend, everything is going to be work with the embedding mode. How fast we are going to read the data and communicate each word together and understand what is the best other words. That all will come into that our LLM model, transformer architecture. In the later session, I will show some example in front of you. Okay. Okay, so I would like to start the today topic. Maybe I'm going to start immediate. So this is the paper I already opened it, right? So here positional encoding. This is what we are planning to discuss today. So in this, I don't like to give you more confusions. In last session, we are discussing about word embedding. Word embedding is nothing but how your word is going to be communicated together and creating the validations. Example, if I'm going to provide some word, yeah, Dinesh, mm, what I can actually do. It's like I mentioned. Okay, so this is the word I'm going to provide as an input. Maybe though is not a clear understanding word. Maybe I'll give you a little bit. Maybe I can change now. Let me take another example. I bought an Apple Watch. Okay, so there is a 5 word I just provided. If suppose I'm going to modify this sentence. Okay, maybe first I will explain what is word embedding. This word, everything will be converted into tokens. So it will be have some vocabulary size values. Based on each word, they will be converted and providing some dictionary values 0, 1, 2, 3, 4, 5, 6, 0, 1, 4, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 2, 3, something. So these are all the vocabulary values. We will be going to feed it. This is going to be communicated together, the word level, how it's reacted. We are not order the value because these are the word. We don't have any ordering references. Everything going to be work in the backend with the vector references only. So vector 1, vector 2, vector 3, vector 4, vector 5. So like that, I just designed this 5 vectors is going to be react based on our token inputs. So at the time, it has to be understand the behavior of their multiple vectorizations, multiple dimension way. So dimension 1, dimension 2, dimension 3, dimension 4. Same like here also multiple dimensions available. Each of the word vector have a different dimension. The GPT-1 they are using with a 700 plus dimension they are using it. GPT-2 they are going with a 1200 to 1500 200 plus. So they are creating multiple dimension. These are all we already had a discussions in last classes. So I don't like to take more time. Directly I am coming to the next point now. After this communications has happened, we will be creating the dimension. We must know the word understanding between this word and this word, how it's close together, how this is close together. Like that, we must understand. Example, the same word I'm going to modify in the different way. Watch and Apple iBot. The same word. If suppose I'm going to send it to the word embedding model, the order I just modified. So same like only this multiple word will be sent into the vector. It doesn't understand what kind of meaning it is. So here I bought an Apple Watch. It's related to electronic devices. So this is Apple Watch is a kind of brand. The dimension followed by brand, company, and your how can you say personalizations. So these are the dimension is going to be check on the backend for you. But if suppose the same word I modified watch and apple I bought. So here it may be considered as a fruit. Okay. So the dimension is going to be bigger in that vegetables and what else I can say food. So this dimension completely modified. The same word, but the meaning is going to be different. How this is going to be understood by your LLM model. Whether it is related to the company branding related or whether it is related to food and vegetable related. There only we are mainly using for our positional encoding concept. Okay. So we are going to stick the word, whatever we are providing as an input as in the token, the positional encoding going to be make in the proper order and hand over to our LLM model. The backend LLM completely running with parallel processing. It doesn't wait and run the sequence model completely in the parallel processing only. So how it's going to be designed, how the parallel processing is happening with the positional encoding, that's we are going to discuss today. Okay, so this is the theory. Hereafter I will go in the mathematical way. Any question, ask me. Any questions, you guys?
Quick question. The difference between LLM and SLM is based on the size, compute size, or how is it
Exactly.
different between SLM and
LLM
SLM?
large language model, SLM small language model. Unfortunately, we don't have a huge competition and we don't have huge dictionary value. That's why we'll be going to reduce the dimension and create a small model. Same only. Concept,
So
algorithm,
the
same. Data
would
value,
be the same.
dictionary values is very less. That's it.
So architecture is same.
Yeah, exactly. We are going to see demo at last. Don't worry. Once you understand all the mathematical terms, then we are going to see in the demo. That's completely in Python. At the time, I would like to give you the parameter inputs for you. So these are all the mathematics for them. That's you are going to study. Okay. Any other questions? Hope you understand what is positional encoding, the theoretical, right? What is the purpose we are using the positional encoding? This is very, very important, guys. If you understand this, then it's easy for you. Otherwise, it's very, very difficult.
The position you are saying this is for MBP processor, massive parallel processing purpose only, Dinesh? Okay.
Yeah, entire LLM going to be run in the massive parallel processing only. Otherwise, it will take more time. You cannot get immediate output, right? Example, you're using GPT model. You're asking questions with one PDF. You will be attached to them and ask for the questions. It's going to be recognize everything together and immediately will be respond back to you. Am I right? It doesn't take more than seconds of 30 seconds. Within a 30 seconds, it's just going to be read entire PDF files and immediately respond back to you. Is it happening? Am I right?
Yeah. Oh, yeah. Oh, yeah. But yeah, whatever you are saying, the positional encoding is help. Yeah, it is especially for the passive parallel processing. This
Yeah.
approach.
Each of the word vector 1, vector 2, vector 3, 4, 5, each of them going to be run with positional encoding only and parallel processing. So the positional encoding plus parallel processing is going to be happen and then only LLM going to be respond back to you. Got it?
Understood. Understood. Yeah. So each and every word is a tokenizing each and identify corresponding domain or whatever, and okay, get output as much quickly. Okay.
Yeah, exactly.
Okay. Let's see
So
how it
first
is
you're following the
positioning.
words. Yeah.
Yeah. Yeah. Yeah.
So
Understood.
your
Understood.
inputs, input going to be converted into token. Token will be sent into the embedding, vector embedding. This vector embedding going to be run with the dimensions. This dimension is going to be worked with positional encoding plus parallel processing. This
Okay.
is
So in the
critical.
sequence of process, the parallel processing is start the last, right? After embedding, and then only.
This dimension created, this dimension only going to be run with your embedding.
Okay.
Positional
Okay.
encoding model. Because there is multiple dimension. And last session we see about the cosine similarity here only. The word embedding and cosine similarity, everything will be discussed here only. Okay, now why
Okay.
positional encoding is important? That's why I provide the two examples, the same sentence and the different example. The meaning is going to be completely that's called a semantic context. Completely the meaning is going to be modified. If suppose position is changed, how particularly LLM model understands the position, how it's going to be respond back to it. Otherwise, the meaning is going to be completely collapse. Am I right? And it has to be understand each of the word. Word one, word two, word three. What is the relationship between them? Everything going to be synced together and addressed system. So this will be taken care by position encoding only. Got it?
Yeah, yeah. This is very important. So the positional encoding is missing, then completely output also wrong,
Yeah,
right?
meaning is going to be collapsed. We cannot get proper output.
Yeah, it's not a meaning. That's so correct. Meaning.
Yeah.
Okay, got it.
Guys, anybody have any questions? This is very, very important. If you are clear, then let me go to the next.
What is the Positional encoding, how does it, what is the right meaning? For example, we use English as a grammar as a reference to know if the meaning is correct, the sentence is correct. With positional encoding, how do we know what is the reference for it?
The grammar, whatever you said, the grammar is going to be aligned based on one sentence only. Am I right? Example, this is you can take. We use sine and cosine function. This is a correct grammar word. You are providing as an input. Correct. Okay.
But how does the system know this is correct?
That's completely we will be using the vector and the tokenization embedding model. Here only we will be using the embedding references. This embedding is nothing but each of the word is correctly aligned. The dimension is correctly available. The grammar check, meaningful.
No, no. So do we add any input to that saying that you need to have this
That's
reference?
that's the embedding model we are doing it. This is the correct sentence or not. This is the correct meaningful or not. This kind of embedding we are doing it. But once everything is done, this embedding can understand properly. This is going to be handed over into our transformer architecture LLM attentions. During this attention layer, how the word, the sequence is going to be aligned. Whether it is in that first should be a zero index, first index, second index, how is going to be understand and in the multi-vector model. So in the word embedding completely vector basis, vector followed by directions. Maybe you maybe check the cosine similarity concept in the last session. That's we will be discussed. Between two word, how it's close together. There is a normal word. Example, um, king. This is coin. How it's close together. This ratio we are seeing in the cosine similarity concept. That's already we have covered. How very close together or how it's deviate between these two words based on the vectorizations. That's already we had discussions. I would like to recall the session, then you will be understand what it is embedding, what is how it's going to be understand the language and so the dimension is nothing but it will be having 1,000 dimension. Each dimension going to be check the criteria. Each word what is the meaning. Each word what kind of activity is going to do that. Is it related to what kind of category is it? Everything will be followed by the dimensions only. Got it? Now dimension understand. Okay, this is okay. We have a connectivity. This is we can use as a runtime, and I'm going to submit into LLM without changing any meaning because he understand the dimension properly. It's just going to be run it. If meaning is going to be deviate, then we cannot get the proper outcome. I mean, I bought an watch Apple Watch. Watch Apple. I bought. Meaning is the word is same, but the position is going to be modified. Then meaning is going to be collapsed. LLM also confused. So these are all the activity we are going to control with the positional encoding. Okay. Now shall we go and start? Any other questions? I would like to request you to check this video, previous cosine similarity word embedding program. Then you will be getting clear idea about this. How each word have a communications and have the similarity reference. So it's completely will be discussed with the dot product. And we see the difference between the cross product and dot product to there. Okay. So kindly watch. If you have any doubt, just ask me one. Okay. Now I'd like to take this one. This is the formula. They're using it. This formula is nothing but the positional encoding for the sine and cosine, how it's going to be behaving. So already I explained to you what is the difference between sine and cosine. So I'd like to call the trigonometry again. This is we are calling adjacent. This is the opposite. This is the hypotenuse. So I'm going to fetch any record and do the validation between these ranges. Between these ranges and these ranges, completely we will be going to check with the sine here. This is for cosine. So this two combination we are going to use for our word, each of the word in the vector, and then we're going to submit in the backend files. So during the time, what it is happening? I'll take Excel. Excel is very easy for me. So example, in the formula I'm going to apply some of the examples. Okay. So positional encoding, this both are same formula only. But you can see the differences here only. 2i plus 1, 2i. And 2i related to sine, 2i plus 1 plus a cos. So this is nothing but your positions of dimension. That's the meaning for them. Okay, so if, like I said above the previous example, I am using a multiple dimension example. That word I said, right? Maybe I'm going to take the word as a 5 letters I took previously. I'll take one example, simple. Thing. No, this is my example. Okay, so this is the token 1, this is token 2, this is token 3, this is token 4. Okay, so total word is, let me take this example with, okay, I will only, so I can mention positional encoding should be for 4 tokens. I'm going to use it now. Okay, so next I want to see the dimensions layer in the backend. So dimension layer, what it is they will be providing here, we'll be going with D model. D model is nothing but dimension. Like vector 1, this word have a different dimensions going to be reacted. Vector 1, vector 2, vector 3, vector 4. These are the dimensions they are going to design. This is their meaning as a D model. This is 4 dimension. Okay, so this is maybe confused. Anybody needs to know about what is dimension? The previous example, I maybe summarized this one, the dimension, because the word is going to confuse you. King is a word. This is I'm going to convert it to the token. So the token I'm going to provide some number to the dictionary format. So token index I'm going to assign it. This token index going to be refer with their behavior, the category of this word. What is the meaning for king or royalty? What is the meaning for this one king? Is a kind of gender as a male. What is the meaning for king? It's a power. So this is going to be assigned the value for this king with this dimensions. So royalty. So king must have huge is a top. Then I will assign the value 0.9. Gender is a male. We don't have other option. Just to be one. The power. Maybe he is a king for a single country. Maybe we have a universe. So maybe I'm going to assign the power for 0.8. This kind of ratio is a kind of validation that the dimension we are going to assign to the vector. So this king have a 4 dimension. So okay, for this example, 3 dimension. So first dimension 0.9, second dimension 1, third dimension 0.8. So this is I'm going to add with some other word. It's going to be compared between these two. King plus queen or king plus woman, something I'm going to compare it. This vector going to be compared with this another one word token vectors. This is happening. So right now the 3 dimension is happening. I take the example for the 4 because it's going to be structurized for this values. Otherwise it might be going to confuse you. Now D model is clear, right everyone? Any questions in D model? Yes, Uma Maheshwari, we already covered tokenizations. First session, byte pair encoding, tokenizations, everything we already discussed. Okay. Meanwhile, anybody have any queries regarding this D model dimensions? Clear or not clear?
So it compares the adjacent word or all the words.
That's why. How is going to be compared? It's not adjacent basis only, right? Maybe we have the connectivity between the opposite meaning as well. Am I right? So he is going to be ruthless. One more word, one more index entry. He is the power. He has a power, so he is going to be behave as a ruthless.
So 2i plus 1.
So this is completely -1. So we cannot assign the value in the similarity basis with adjacent. It might be opposite. That's the reason we'll be creating with the sine and cosine. Sine completely going with opposite directions, cosine going with adjacent directions.
Okay.
Got it?
Yeah. So just how 2i plus 1 relates here in this.
I'll come to the next one. First, the dimension model is clear. Then I will explain one by one the
Yeah,
formula, and then
I
I'll
understood.
come.
Understood.
Others? Anybody have any questions? Is it clear, everyone? Still confused?
Sorry,
How
go.
these dimensions are decided? Like, is it from the dictionary, or like how these like royalty, gender, power, or for any other word? How these are decided?
Based on the vocabulary size. Each LLM model we will be going to feed based on some vocabulary sizes only. That's going to be defined the dimension. How many vocabs you're going to use it? That's going to be defined to yourself. So right now, this for positional encoding with the GPT-1 model, just 50K dimension vocabulary size is using. GPT-2, 3, they are going with a million level. So this is will make the permutation combination based on your token input. It doesn't take all the words together. It's just going to be provide what are the input as a sentence. It's going to be check all the dimension references. So this 50K records that word tokenization going to be assigned with 768 dimensions for time being of GPT-1. GPT-2, GPT-3, they are increasing. But as of now, for study purpose, we are not take 768 here. We are going to take samples only with the 3 or 4. That's it. Otherwise, it's going to be confused a lot. You cannot understand. Got it?
So you're saying
Real LLM,
that's the reference for 50K reference for the model to understand these connections,
real
these
LLM,
dimensions.
real LLM GPT-1 going to be take 50K vocabulary size, 768 dimensions, matrix dimension.
Seven
And this is
sixty eight dimension means like
Each word
yeah,
has a
seven
768.
sixty
I
eight
will be going to check with the 768.
60 dimensions.
I am going to check with the 768.
Oh.
So each word is going to be checked 768.
768.
Some of them will be have meaning, some of them doesn't have meaning, then it will be brought as a 0. Got it?
Okay. Yeah, okay, 768.
Is this clear now? Shall I go next?
Yeah, I think so.
We're playing this game. So like I said before, dimension, there's a 4 I'm taking. For the example, real time already I mentioned, 768. For your understanding D model. Okay. Second, word. I am giving the word 4 only. I can mention the word is kind of K. I can this one. Or N I can provide. N is a kind of advanced professor. So they are calling as a K. This is a word. K is nothing but word. Okay. And then this 10,000 what it is mean? This is your question, am I right? Why it is 10,000? Can anybody guess? What is 10,000 here? Can anybody discuss about this architecture? Anybody open this research paper before?
No, we are seeing it first time.
Okay, this is the basic of architecture model. You can see there before it. The wavelength form of geometric position from 2 pi to 10,000,
Sure.
which means what is it? Our wavelength. What is mean by pi and 2 pi? Okay, how many degrees is available in our circle?
360
Yeah,
degrees.
360.
360.
What is the difference between radians and degrees?
Oh my god.
This
One is
is
the
what we had discussed last class.
Okay, I was not there.
you have 2 pi r, right? 2 pi. So 2 pi is the radians.
That's why. What is 2 pi? What is 2 pi?
2 pi's.
So like you have gain one thing, right? 180 degrees is your pi and 360 degrees.
Yeah, exactly. 0 is nothing but normal. Pi by 2 is a 90 degree. Pi is 180 degree. 2 pi means 360 degree. So what they are saying, the wavelength, the difference between 2 pi to 10,000, 10,000 or 1 million, 1 lakh something. So this is the direction. Each vector moving to this direction with this much value. So 360 will be going to reach with a 10,000 or 1 million wavelengths. Thus they are trying to meaning it here. Now you got the point?
I got the 2 pi, but not the 10,000 thing.
Not the 10,000, yeah.
No, this is their research purpose. They are using it because they need to get the clear accuracy. That's why they are using with 10,000. You may be going to use with the less also no problem. But this is completely providing the geometric progressions from 2 pi. Okay, if suppose they are going to use only 10, what will happen? Any guess?
So the
Accuracy
length
going
of
to be
the
low.
part will be small, yeah.
Order frequency.
Accuracy going to be low because it doesn't connect between these two words. What is the meaning between I and? This connectivity they are going to check with a 10,000 basis on the wavelength. So they are going to make all the iteration with the 10,000 real time. So here they are going to use 768 dimension, the different places. Here the one dimension, second year, 1,000 year, sorry, 100 year, 700 year, 768 year. Like that, they are going to assign their positional on this wavelength for one vector dimension. Like that, they are using different dimensions. That's why I say dimension model will be using more than vector based on our vector size. We can use with the 768 layers. If supposed to assign this way, we will be going to use multiple ways together. Then it's going to be provide a very good accuracy because this is a one single length. Same like another word. This is for I.
So
And this is an aspect.
are you saying it's more like a number of iterations? It is referencing to that
It's not
760.
iteration. Iteration is a complex number. Okay, so can you go to the mute? This is the complex number. It's not iteration. Example: one word, one vector is available. Vector one have 100. 100 is a kind of direction is going with that. Plus positional encoding is a complex value. Positional encoding of I. Something you remember this complex numbers?
Yeah, not the whole number.
100 plus 7j, 200 plus 9j, something. These are the complex numbers. This complex number, positional encoding is a complex number for you. This is your vector value. Both will be working together, but it doesn't addition. It doesn't calculate. It's not 107. 100 plus 7G. 200 plus 9G. So in this direction, 7th position, 100 value is going to be stored. 200 value, the vector value is going to store on 9th position. Something like they're going to assign it. You got the point? Or would you like to see some demo and then I can go in the mathematical way? What's your expectation?
I think
Because
we should proceed, and as we go forward, we'll clear those.
that's better, I guess so. Because I would like to understand. Understanding is important. Then we can see in the mathematical what.
Can we have some more examples of this complex numbers?
Wait a
Just
minute. I will
understand.
show the example. I already take the examples in full.
Okay, okay.
Okay. So this is I am using with 6 dimension with 40 inputs. Okay. So you can see all the series. I'll take only 4 right now. You can see the first one. This is very clear, right? Or can I make it a little bit more?
Yes, it's clear.
This is a dimension 1. This is dimension 2. This is dimension 3. This is dimension 4. Each dimension have a different wavelength. You got it? This is a different wavelength. This is a different wavelength. First dimension, you can see the value start from 0. Got it? You can see this value. In this value, you can see this one. The value start from 0. Okay, maybe I'll take 2. Dimension 1 and dimension 2. I'll take this. You can see first dimension start from 0. Another one dimension start from 1. What is the meaning for that?
Is it zero position?
Yeah, why it is 0 position? Why it is 1 position? Why it's starting from 1? Why it's starting from 0? Based on this positional indexes.
Wavelength.
Sine always starts from even numbers. Cos always starts from odd numbers. Okay, so this is even number. This is odd. Even so sine of 0, what is the meaning? Example I'm asking. Sine of 0. Can you check? Sine of 0 should be a 0. Cos 0.
0 is 1, I think.
Yeah, that's why this is the even number dimension start from 0. This is odd number dimension start from 1. Now you got the idea, right? So this is the first position just started. Same like each n dimension is going to be point in the different way and showing the output. Do you want to see the point? Now this is clear, right? Till now everyone is clear? I'll show the point aspect. Then you'll get some idea. Here I just assign the value. Maybe I'm going to change the design. Try this one. It's very clumsy. Maybe I'll take only one right now. You can filter and see the responses. Okay. As of now, I take position 1 is a 0. Position 2 start from 0.84. Position 3 0.909. Position 4 0.14. This one 5. Point possible. I'll do the plot aspect. I don't know exact point. I cannot point it here, but you can understand this one. This is a position 0 here only. I would like to show the point here. So this is position 0. Might be position 1, 0.84. It should be here. 0.9. It should be here. Position 4, 0.14. It should be in here. Position 5 minus 0.75. It should be here. 0.95. It should be in here. Same like I have take almost 60 dimensions around. It's just going to be travel in this way. There's the only one value. 100 plus something, the position encoding value, position encoding of 60. I'm going to pass it. This 100 is going to be travel this vector value in this way only. It's going to be run this way only. Okay, this is the vector 1. Same like vector 2. Vector 2 is a dimension 2. This is a dimension 1. So vector 2 is going to be run with, sorry, this is dimension 0, this is dimension 1. So vector 1 always go with even number, that's why we are using a sign. Vector 2 will be going with odd number, we are taking from cosine. That's why another one vector going this way. So both will be traveling together, but it's following with a different position. This connectivity will help to make our complex values proper accurate. So 100 plus position 60 vector plus 200 plus position encoding value of 60 is going to be run together. This value is going to be added in your LLM model in for the vector embedding. So in this case, it's a parallel processing, vector going on the parallel way, but both of them reaching the same directions within the same time. So mean should be in the same. It doesn't change the value between these two. Position 1, position 2, position 3, whatever in the position way, it just move. Same like position 1 of cosine is available here. Position 2, cosine value should be available here. Like that is going to be happening. I'll take position 2 also, one more dimension. Both running together in the parallel way, not with the sequence. This is the direction of your vector, not with the value. In this direction only, the wavelength is going to be that vector wavelength is moving. Okay, how many of you know about Fourier transform? Anybody have knowledge in that audio platform? Fourier transform is a kind of one more wavelength algorithm. How our audio going to be converted to sine model. This wavelength only going to be generated in the backend. Same, the vector is going to be run in the way and everything going to be submit into LLM, the same positional structure. This is happening. Now, what we are planning, now, till now everyone is clear? Or still not clear? Is it clear, everyone? Say yes or no. That's why
Yeah,
I
partially,
need to explain the
not completely.
access.
Yeah, max class, right? But the high level understanding then is, see, this encoding, right? It will help to progress the wavelength of to identify the dimensions. So how fast is going to progressing, right? That's what is going
That's
to
part
help to, yeah. Okay,
yeah,
okay.
please go ahead, please go ahead, please go ahead.
Yeah, that is a high level understanding. So this is a algorithm, whatever you call. Okay. So this encoding functionality or approach will help us to progress to identify how quickly identify which domain or which. Okay, that's what the parallelism. So whatever parallelism, these are all things we have to enable. So the finally, what our understanding is how quickly, how the velocity of the progressing of the yeah things, right?
Vectors.
That's all vectors. Vectors.
Yeah, we
These
have
are my
used the dimensions of
understanding.
vector. As of my understanding, you understand what is vector, what is a dimension. Right now,
Ah,
how the parallel process is moving on. which
Yes.
direction that vector value is moving on. This is all of you. Hope you're clear. I guess. Am I right? I'm still confused.
Yeah.
That's why I plan to show the math and then I'll come to this one. But for understanding, I just reverse it. Now I can show all the values for you. Now I'm going to create how this value is generated by Positional encoding. That's we are going to discuss. This is a reverse mechanism. Till now, everyone is clear on we are on the same page or is confused? Math is bit interesting, but if you are not understanding, then it's making you very complex. So tell me now, if you are clear, then we can discuss. Or if you need, I can repeat again.
Need repeat.
Okay, fine. Just a short. Okay. So this is the formula. We understand what this formula is provided by our attention paper itself. So research paper they are providing the LLM is going to be bigger based on this formula only. We are going to discuss how this formula working. Why is cos? Why is sine? Why the 10,000 K they are using it? What is the reason for the dimension model? Which we have discussed. 2i plus 1, 2i. This is the reason for odd or even. Any value comes as it is with a 2i, then it's a sine. It's an even number. 2i plus 1 should be an odd number. So all your dimension 0 to dimension n, whatever you're going to use, dimension 1 or 2, whatever, all even dimension going with the sine positions. All odd dimension going with the cos basis one. Formula, everything is the same. This output going to be generated the sine value and cos value going to be different. So we are taking the example right now in that output of the chart. We are taking only two examples: dimension 1, dimension 0. How it's going to be work with the sine, how it's working with the cos. So we are seeing some values. Sine start from 0 and it will be going on. Cos start from 1 and it's going on this way. So how is going to be travel? This is nothing but your vector. This is the vector. This is another vector. The vector traveling on this the dimensions of your sine and cosine references only. So this is the travel of your directions of vector value to 0 vector value. Okay. Same like we have a n number of dimension, we are going to use it. This n number of dimension will be run in the parallel because there is no interruption between, there is no dependency. I can run sine separate, cos separate, right? It will be travel in this wavelength without any interruption. Both will be running together and will be synced together. So
each
mean should be in the
dimension has
main.
both sine and cos, or is how is it? Each dimension has to have both. Each dimension should have both sine and cos PE, or no?
No, dimension, no, one word. Oh, we can take one word. Example, hello. This word, we are using multiple dimension.
Right,
Okay, dimension 0, dimension 1, dimension 2. But all together, then only we can get the same meaning. Am I right?
right, yeah,
So this is already I mentioned, this is the dimension is nothing but a category for your understanding.
yeah.
Category 1, everything will be combined, then only hello meanings is a greeting, something we can understand, LLM can understand. So everything we are going to submit into our LLM model, but not in the sequence. First D0 and then D1 and then D2. Not like that. We are not
Yeah, in
submitting.
parallel. Yeah, right.
This is a parallel. This is
Yeah,
will be traveling. This is will be traveling. This will be traveling the direction. But everything will be running together. How it's running together without meaning changes. There only this positional encoding will be helping to running without any interruption to others. Got it?
So
Yep.
these are the wavelengths which will be traveling with
Your vector value,
non-sequential
your dimension
vector
value.
values.
Exactly.
So like
That's why
you
I said.
mentioned for 50,000 watts, there are 700, 700 plus dimensions for
Exactly.
GPT-1. Okay.
Exactly. GPT-1, 768 dimensions, they are going to run for you at once.
Mm-hmm. So
That's
this
why
wavelength,
within a second
wavelength
you
is it
get the output.
wavelength means is it an audio or it's a kind like I'm not getting this one. Why wavelength?
Yeah.
For understanding purpose, it's not audio. Just in the back end, the data is going to be submitted to LLM model, right? That are parallel processing. Each of them will be
Okay.
traveling this same length. Then only it can have a meaning.
Okay.
Sine square plus cos square. What is the meaning?
One, no?
One. So this is the wavelength is going to be run for you and combine together and produce the output to you. Okay. LLM can understand dimension 1 and dimension 0, dimension 2, everything for the meaning for hello. Everything going to be reach into your LLM at the same time with this different directions. But everything in the parallel, not in the sequence. Got it? Then only LLM can understand, okay, dimensions 1, 0, 2, everything will be combined together for the hello is only one word. Same like another one direction is going to start for another one word. It will take more time. Something like each of the direction is going to be run for you. But everything run in the parallel with the GPU support. That's we are calling as a flops. Maybe GPU architecture later we can discuss. I don't want to confuse now. But in the parallel processing is happening this way only.
Okay.
Got it?
Dinesh, so I'm sorry to interrupt you. Maybe it's, I have a question, but it's meaningful. I'm not sure. But this wavelength, right, to travel that dimensions, only is cos and sine, okay, even or odd. Okay, there is a possible only two wavelength. Then maximum two parallel only is possible, right? So how it is multiple wavelength? How it is come then?
No, this is one position is going to be run at.
Oh, one
We are plotting
position.
multiple
Okay.
dimensions. Dimensions we are going to submit into this. All the dimensions following this formula to so travel to your processor. So LLM
Okay.
can reach at the time in this length only. Then only meaning doesn't change it. What is the purpose of position encoding? We are using it. Meaning should not change. Okay.
Uh-huh.
First word should be hi. I bought previous example. I bought an Apple Watch. Okay. So first word should be this one. It must be in the first. It have a four dimension. Four dimension will be travel into same time with this direction way. Same like bot have a four dimension. For example, I'm saying four. It's we are using a different model with the 700 plus. For understanding purpose, I'm taking only four. Otherwise, it may be confusing you. Even I'm taking only two as of now, not two, not four. One for odd, one for
Okay.
even. I take. I'm right. So only two dimension. One for odd, one for even. So odd is nothing but cos basis. Even is nothing but sine basis. This is the way of saying. Saying like multiple dimensions will be joined together. Hope you see the example, right? I'm clearing this thing now. Only two dimension as of now. If suppose you are going to use multiple dimension, maybe remove that text. Okay, like this, the different dimension is traveling to reach into LLM with this value, with their meaningful value. These are all running together and submit into a dimension at once. That's unimportant. Got it? Oh, real time. No, I don't want to confuse you more math. Okay, so right now this is fine. Maybe later session I'll tell you. Different between sine and cos we have to discuss. Okay, so now you understand, right, how it is behaving. You can see only I take six dimension. All three start from zero. All three start from one only. So three is a sine value, which means even. Three is a cos value, which means odd. So total six dimension. I just split up. Three will start from one. Three will start from zero. Because this is all followed by sine value, this is all followed by cos value. Now you got it? Clear, guys? I'm trying my level best to be frank.
Maybe we can have some practical, then we can understand much better. It's clear from sine and cos value how the even numbers are
Okay.
generated and odd
The
numbers are
direction
generated.
you understand, right? Why
Yeah.
this direction is important? Positional encoding, why it is better? This is everyone is clear.
The
Mainly
purpose we know, right?
word.
The meaning of the purpose we know that. Okay, so exactly we are asking, yeah, what is the purpose? Okay, we are going for this one. I got it. As per my concern.
Okay, fine. Maybe I will run the Python programming and will show the same output in front of it. No problem. Okay. So shall I go to the programming, or do you want to know the math behind? How you expect?
I think math is
Okay,
enough. We can for the code.
I'll do one thing. I'll make the simplifications for this one. Okay, I don't want to confuse a lot. I'll run the query. I will see the output, and only one example I'll take, and will show the output to you. Okay, that's easy for me. I'm trying to make it a very simplification. First, I'm going to check code. I run the code and we'll see the output, and then what I'm going to do, I'm going to take one code and how its math is value is going to be assigned.